Já temos 14 a observar. Standard. Exato. E agora o que é que vem? Já estou a ouvir. Agora estou. Deixa lá ver. Isto é... All right. Good morning, everyone. No. Good morning, everyone. Welcome to CommitPorto' 2020 stay-at-home edition. This is the first time we do it in this format, and obviously for the obvious reason that you all are aware of, I'm sure. This has been a weird year, I'm sure, for you as well. But we're very happy that we were able to gather such an awesome group of speakers for today. And so we have I believe, 6 talks, if I'm not mistaken. And exactly. And we have 3 giveaways. If you've been following our social networks, you'll know about this. And you'll know that to be able to qualify for the giveaway, you have to ask your questions on Slido. We do have YouTube chat open in case you want to discuss things and ask any questions to the organization there. But if you want to ask questions to the speakers for each presentation, you do have to use Slido. And then Slido allows you to vote each other's questions and help selecting the most interesting ones, so that then we can ask our speakers after the presentation. And then from that list of selected questions, will be elected the winners for the giveaway. We're gonna have 3 giveaways of 100 euros each in a Amazon gift card that you can use to buy a headset or something else actually, but that might be useful in this time of video conferencing and online conferences. Who knows if in the future you'll need one to present your work in a conference like this one. So we will have our first speaker starting at 10:15 Porto time, and we'll have Daniel Ferrari, who's going to be talking about asynchronous machine learning inference with Celery and Fast API. In a moment, I will bring Daniel into this call so that I can introduce him a bit and get things ready to start. But we're starting at 10:15. So we still have a few minutes. Obviously, this wouldn't be possible. CommitPorto wouldn't be possible without the support of our sponsors and our partners. And we'll be also introducing them along the day. And but you can already see them on our holding screen now. So we have the Department of Informatics Engineering from the Faculty of Engineering of the University of Porto. We have BIT. We have OutSystems, Critical TechWorks, Darwin, and my eyes bit me because there's digital labs there. I'm getting old. So let me try it. So this is the first time, as I said, that we're doing this live webinar conference. So we're using a bunch of technologies that everyone's probably familiar with, but I hope it's not too bumpy as we go along. Let me maybe I can. Well, I just looked at my face. I'm a bit mixed with our sponsors because it seems that my wall is not as different from my own face. So I hope it's still clear and it's not too weird. We still have a few minutes. Let's see how we're doing in our live thing, because it's a lot of, I need more screens. Wow, 31 people. Good morning, everyone. Welcome to CommitPorto 2020. I'm gonna, let me see if I can pin Danielle. Let's see if this works, Danielle. Hi, you're now
Hello.
The spotlight, I'm sure. And we still have a few minutes, but we can chat a little. How are you doing?
I'm fine.
Where are you based, if I may ask?
Porto. I am Porto.
Oh, you're in Porto.
Yes.
Cool.
So you're in the same time zone with the same beautiful sun today.
Yeah. Seems that the autumn hasn't completely arrived yet. So it wasn't. It wouldn't be very difficult for you to actually join us in person. Have you been to any CommitPorto
No, the first one.
Okay, good. Hope you enjoyed. Things always go a bit faster than I thought. So I thought that the 50 minutes would be enough. I hope I didn't forget anything. I'll make sure. My colleagues from CommitPorto. Oh, by the way, I should have probably have said that CommitPorto is organized by Alumni. So the alumni association from the informatics engineering students of FIOP, so the Faculty of Engineering. It's quite a mouthful, but we've been doing CommitPorto for a few years now, and it's been always a great experience and a great set of speakers. And we're at it again. We're a bit scared at some point because of COVID that we might not be able to do it, but thankfully we were. And so this is our sixth edition, and it's the most different one, I guess, in terms of setup. All right. Do you have any questions? Any? We have 5 minutes to kill before we have to start. I don't know if anyone in the live chat has any
It's my first time doing this like remote presentation remote. Usually I enjoy the be in person, talk with people, so it's gonna be a different experience also.
Yeah, it's true. It's there's no networking, so we do have like a few, like we'll be on social networks obviously, and we have the YouTube chat, which allows for some conversation, but it is a bit different, and there's no catering or coffee breaks, so everyone has to take care of their own coffee breaks. But it takes a little bit of the magic, but it is quite good that we can still do this, I think. And now obviously I have I'm the lucky the lucky one that gets to speak with all the speakers and gets to know them a little more. So I'm in a lucky spot today. So at some point I will ask you to share your screen. I do have a holding slide that I can start showing, I think. Let me check. Where's this one? I'll start with sharing my screen and then I'll pass it on to you.
Okay.
No, just to get the right screen. It's always a bit challenging. So this should be showing Keynote. Can you confirm that that's what it's showing, or?
It's still in the loading screen.
Okay.
At least for me.
Oh yeah. Okay. Sorry. Yeah. I guess it's my loading screen. And this is you, right?
Yes.
Good. Just to make sure I know which screen I'm sharing. But yeah, so for everyone watching on YouTube, I will say it again. You can ask questions on Slido. You can get to Slido either through this QR code on the presentation or also from our website, CommitPorto'20. So you'll have to sign up with your email and the real name, please, so that we can find you if you are the lucky winner of an Amazon gift card. Also, you can only win one, but don't let that deter you from making awesome questions throughout the day, because that also makes our conference better when we get and this is like always a unique opportunity to ask people to clarify things and to know a bit better what's going on in their topic, in their field, and how well, anything basically. I'm not going to try to come up with examples. I'm sure everyone can come up with their own examples. We are less than a minute away, so Danielle, I will stop sharing my screen so that you can start sharing, and we can start with a certainty that we are not doing anything wrong. So I will stop my share. I think you should be able to now share your screen.
Okay, I think it's working.
It is. I can see it.
The presentation slide, right?
Yeah, exactly.
Awesome. Let me know when I should start.
All right. I think you're good.
Okay. So welcome everyone. I hope everyone is safe at home. I am Daniel. I'm gonna talk to you about machine learning, asynchronous machine learning inference using Celery and Fast API. I want to thank you, the CommitPorto' organization, for give this opportunity to give this talk to you, and I hope you all enjoy and make questions, and we can interact as best as possible. I'm gonna talk a little about asynchronous and synchronous requests, some response mechanisms for asynchronous requests, some architecture design details, that is the focal point for this presentation. Also, how can you scale everything with Fast API and Celery? A brief overview on the Python code that is gonna be shown in the live demo. If everything's gone well, we have a lot of demo. And at the end, the goods and the bads on in architecture that I am showing to you. So what's the synchronous and asynchronous requests for HTTP, right? Synchronous requests are the requests that blocks the client, and the client will wait for the response, in this case for the ML inference, right? So the client send the request and will be blocked waiting for that response. And the asynchronous request is that the one that you send the request and the client's free for do things. So if you are in a web app or in a mobile app, you can interact with your app, and after some minutes we will receive the response and do things with that response, so you don't be blocked by your request. And why we use asynchronous inference for machine learning? So there are a lot of use cases. I just point 3 here. That's the most common ones. Every time that you are doing with large files that cannot be submitted inside the request, you need to upload the file or send the link to download the file. For audio transcription or video processing, some things that you can do here. Also, when you have to do with several files, right? You have like to do a bulk image or text annotation or some NLP operation in a bunch of files. So it's complicated. You don't want to be your client waiting for that process. Let him do another thing when you are doing this work. The other use case I put here is not the inference itself, right? But it's becoming very, very common for providers for machine learning, that is allowing the client or the person that buys the service extend the model, do some customization or personalization. Right? You send more data to the provider. He will train the model, extending the existing model, allow you to have better results for your personal use case, right? So this is not inference, but is machine learning. So, and it's becoming very, very common for the providers. And what mechanisms for the response do you have? So basically there are 3, but and I think is the most important ones. You have the pooling, so the client sends the request and receives a job ID, and the client needs to keep pooling, asking the server if the job's done to receive the result, right? The main concern here is that the client needs to control this pooling mechanism to not hit any limits on the API side. So don't be blocked by trying to overload the API with a lot of requests. The callback mechanisms, it's a little more complicated, right? Because the clients need to have an endpoint to receive the response, and the server will make a post on that endpoint with the response. The problem here is sometimes the client is unable to have this kind of mechanism, like a post endpoint. And also the authentications and the security around here is more complicated, it's hard to deal with. So it's hard to have, it's hard to see machine learning providers enabling callbacks with endpoints. But a lot of them do notifications, and notifications are easy to do. Instead, have a callback, you have a notification system, right? A notification system can be an email, an SMS, something on Slack, can be the notification. And the notification is easier to process, right? You don't need to a very hard authentication because it's an email, or is Slack, you can send a token. SMS, you have phone numbers to guarantee that everything is going okay. So its notification is a little, it's a little easier than callback. In pooling is that they usually do for everybody. So what's the proposal architecture here using Celery and Fast API, right? You have the clients, and the APIs work as a gateway for all your machine learning services. You can have one API for everybody, for everything, or one API for context, right? One API just for image service, one API just for NLP, for video, for image, for forecasting. So you can like have one API for each kind of machine learning work that you want to do. The broker is where all the tasks for the workers are the process that really have the machine learning process, right? Have the model, will do the inference. So the broker works as a routing, where the tasks are are routed to the correct workers, right? So the broker that we are going to use here is a RabbitMQ, but can be Kafka, can be other things like SQS from AWS, can be a lot of brokers that you have on the internet. And Celery will provide all communications with the brokers for the workers. The backend is a database where the response is going to be stored, and the API will consult the backend to understand if the job's done and what is the response. And for this, the backend is going to be a REDS database. And the nice thing here with heads that we can create a TTL for the keys. A TTL is time to live, right? So you can say that the response have 24 hours on the database. After that, will be automatically deleted. So this is nice because provide some control on the size of the database. The database not grow forever. You can have like a size control for a database. That is nice. It's kind of for free. So how to scale? Fast API. Fast API is a new framework for Python. It's getting very popular. It's very fast, a very fast API. Has a very nice HTTP server that's unicorn, and it's ready production. It's easy to learn, fast to code. It uses the latest async native from Python. That's very nice to do async work is inside the API. It makes data validation easy using PyDent. It's very easy to do validate the requests, and if the data is all correct, it's not mistakes. And it's very easy to document with OpenAPI. You just document the code, and the document you just put everything on the code, and the framework, the Fast API, will generate the document for you. So it's very, very, very nice. And it's easy to scale in any machine. You have a lot of, you can do, the unicorn can have a lot of threads. You can use a Kubernetes approach to scale, and since it's not having the model inside the API, it's very small process and can be scaled very easy. Celery, it's a kind of old broker and worker system on Python, usually to do background jobs for the Django. It's very common for the Django have this behind them, but you can use this to organize your workers and have a broker organizing all the scale. So you have a broker that can provide you high availability, because you can have like a cluster of rabbits and queues, like with 3, 4, 5 machines. So you have like resilience for your machines. And the queues can have a lot of workers, so you can have scaling, just adding new process. Celery will deal with all communication, broker and backend communication, so it's easy to organize this. And Celery also has auto scaler internal, so that you can provide in the same worker more than one process, and you can scale this process inside the worker. And another nice thing that I think from Celery is that the tasks that are generated for the workers don't need to come from Celery, right? It's an open protocol, it's a JSON that anyone that can just post a message inside the broker, push a message there, can work. So you can have your APIs on other languages like Go, Java, or Kotlin, or whatever that language that you work, even JavaScript or Node.js, and just publish the message inside the broker with the same format. Celery will understand, do the work, and send a response to the backend, and everything is gonna work without any problem. So I wanna do a very brief overview over the code that I'm gonna show you. The full code can be found in GitHub. If you have any doubts, you just ask me, and I will be very happy to talk to you. And also I use this slides code highlighter that it's very nice, and make the presentation around the coding format is very nice. So this is just a tip for the ones that like to do presentations. And it makes this colorful thing very beautiful for the codes. So how to implement the worker with Celery, right? It's similar to any API framework that you must already use, like Flask or Fast API or Django. You need to create an app Celery, give a name, and connect to the broker in the backend. It's that. You do a notation inside any function that you have. So the function here, it's not very complicated. It's a very simple function just to show that anything can be done, right? So I am receiving a link for a file that what I will try to load the file, download the file, and load inside the memory, and then I will split the file to get every speed segment for that file. So I can use this to decrease the size of the file, for example, to do transcriptions. Transcriptions are charged by minutes, so you can take out the silence to have a lower cost on your transcription. And so this is like a pre-processing step for transcription. But I can do everything in the same task. I can do pre-processing, do the inference that I want, and then post-processing, and then send the response. So this is just a brief overview. If something fails, Celery has ways to tell that the task failed for some reason. Here is that I was unable to do download of the audio. Maybe the link is wrong, or the file was deleted, you don't know. So you can raise an exception, and this will tell the framework, okay, this fails, and I can give a reason for my client, and the client asks for the response. It knows that's fair and why it's failing. And I use using LibRosa, that's now a famous auto-processing library, to do the simulation for speech and get the speech segments here. The endpoint needs to be implemented with Fast API and Celery, right? Because it needs to know where to send the task and where to get the results. So I have a Fast API app, I'll have a Celery app, that's easy. I have a class with Pydent that will be the body of the post request and will be automatically validated for the Pydantic and Fast API. So I don't need to do data validation from the post. So if the callback, it's not a Boolean, it's a string or it's a list or something, it's gonna fail automatically and send a response for the client. So it's easier to do things here. And the task, the endpoint is annotated, similar to the Flask, for example. It's very easy to do. I want to send the audio task. So the audio, it's the Celery app. I will send the task with the name, the parameters, and the queue that I want to send. So I have a very simple implementation. Instead, the queue, I could also use like a routing key that Rabbit allows this too, but I use here direct queues to make it easier. And I am using a feature from Fast API that background tasks, sorry, to simulate a callback, right? Not the callback from endpoint, post endpoint or notification, whatever. This idea is background tasks on Fast API. It's a queue of threads. So you launch a thread to this send result. That's another function that I will show later to this task ID. So if the client wants, it send through to the callback, and I will send a callback to them, right? So this is just a simulation to understand how can a callback be used with Fast API, for example. The response endpoint, it's a get endpoint with the task ID. You can request the Celery app for the result, and the result will be if it's done or it's not done, if it's success or if it's fail, right? I build my output here with the task ID, the state. If it's fail, I send an error message. If it's success, I send the result for the client, and I put the endpoint here with a JSON with 200 and the content of the post, the post of the response for the get endpoint. It's very simple. And the send result, that is the backend. It's not query, it's just for very demo. So it's a while true. This could be better. Instead, do a while true could be something more friendly to the data backend. So I will keep asking the result until the result is ready. Maybe fail or success. I don't need it to know. I will build the same response from the get endpoint. So the identical object is the same here, right? And just to everybody see what's happening with the backend, we are going to see a print on the console with the output. So I can be post for something, I can do a Slack notification, I can do anything that I want here. I just need to send the result somewhere. And the thread will be closed and go to the next background task, and this will be keeping up and running. So if everything go right, I can do a brief demo. I have Docker running, Rabbit and Reds for me, right? So I don't need to the implementation. It was the base image for them. And I will run my worker, and I will load my API here. So, sorry, here is wrong, run API, okay. The API is very simple, right? Just HTTP server up here on the worker. I can see that is connected to the Rabbit, it's connected to the Reds. I have two workers inside this process, so there is two workers working here. It's connected to this audio queue that's gonna have this exchange and this key to routing the tasks. This worker is responsible just for one task, but you can have one worker responsible for more than one task, right? You can have a lot of functions around audio, and the worker can do everything that it needs. So it's just that. And I have a little client here that is just a Python script that have some links for audio files on the internet. Some links will fail because I just put them wrong to check if the response of fail is it's working or not, right? So it's gonna send everything to the API. You can see like a lot of posts here, and you can see on the log on the Celery, it starts to executing the tasks with the parameters, the link for the file, and start to give the responses if it fails, if not fails, and everything. Here on the API, you can see where the callback is working. So my callback is working for 50% of the requests. So some have callback, some not have callback. So it's random choose. And my client is waiting here, and I will just push, they will get the results. And one thing that I want to show here, okay, so I get the result for everything that is done, success and failure. And I have some pending work. And here, when you have this pending, you have to do the request for the response again, right? So this is the pooling mechanism that you have to implement. I didn't have this implemented here because I want to show you this will be the state that you receive, pending, and okay, if it's pending, it's not done, I need to ask again. So give like 30 seconds or 5 seconds and ask again for the server. Okay, it's done now. And if it's failure or if it's success, you know what's happened here. Everything works well. The codes have a lot of things, have a Docker Compose with everything to do end-to-end tests, but you can go there and see, and everything is okay, and this kind of stuff. The goods and the bads, right? Not everything is perfect. So the good things around this architecture that I think is that you can, in the same infrastructure, you can have several machine learning models. You can do deep learning, you can do MLP, you can do image, you can do forecasting, you can do audio, you can do everything that you need inside the same thing, right? So don't have to create a lot of architecture around this. It's easy to scale in both sides, and both sides have different strategies for deploy and scaling, right? Scaling APIs, it's very easy. Everybody it's used to do scaling APIs. You can use a Heroku, you can use a Kubernetes, you can use anything that you want to do this. And for machine learning, it's very different, right? You can support any machine size. You can have small machines for easy machine learning, or you can have big machines with GPU for deep learning to accelerate the process. So since you have two different scopes, you can scale them with a strategy appropriate for the machine that you have. And for me, it also allows machine learning engineers and data science code closer, because data science will be closer to the worker doing the pre-processing functions, the inference, and the post-processing functions, when the machine learning engineers will work with the API, the infrastructure with the broker, and the backend, and everything that the worker needs to be scalable, they can solve this. The bad things, okay? You have extra infrastructure to manage. You have a broker and in the backend to manage that you don't need if you have the API and the machine learning model in the same machine. So this is something that you need. It's a little harder to create end-to-end tests. It's not impossible. It's a little complicated, but it's doable. This infrastructure, this design, this architecture can be used for synchronous requests, right? Will add some extra delay, but it's not that much. You can have priority keys on the broker and do very fast, but add some extra delay. But you can use for synchronous and keep this responsibility of the API and the machine learning work separate in different process. Celery hides the infra complexities. That's not so bad, but it's important that when you are working with the broker and the backend, you know them well and know how to tuning, how to parameterize, how to configure them. So Celery hides this, and this sometimes is bad, and you don't know what's happened because Celery do some configuration that you don't see. So you need to be aware what things can be done. And using the background task from FastAPI, it's not the best way to consume the results for back callbacks. I am trying to find a different way. I spent some time with the code and didn't find something very bad, very better than that. So that's the end goal for my next, for the future, is find a way to not have one thread for each background task, but to have like consumers and that can consume the response as the response is ready. I don't need to ask the backend will tell me when the response is done. So I am working on this for now. If you have an idea or if you already did this, please read me. I will be very glad to talk with you. And that's all for me. Thank you, everybody. If you have any questions, and we can go to Simon to organize this.
Thank you, Daniel. Before we move into the QA, we'll just share a small promotional video from one of our sponsors, and we'll get back to you guys with the questions afterwards. Thank you very much, Daniel. I'm still getting the hang of this. So thank you to Bit from Sonai for their sponsorship. I'm gonna now try to pin you and myself, Danielle, so that well, we can pretend that this is a conversation, even though the questions are mine. But thanks to our audience, we have three or four questions. So I'll start from the top. So the question that came up is, can you optimize task affinity to certain node structures? So nodes with bigger memory do memory intensive tasks. Nodes with a better CPU do CPU intensive tasks.
Yes, right, because the workers are independent machines. So you can have a machine more towards to CPU and another machine more towards to memory task, right? And they will consume tasks from different queues. So you can have several different queues, and the tasks will be different, and the machines itself will gonna be different, right? So you can routing the tasks for virtually anything that you want.
All right. Thank you very much. In terms of advantages, is it better to choose longer tasks? I think what's more advantageous, choosing longer tasks in order to keep everything in one node, or is it better to keep it small? So what is like the optimum approach there?
This is complicated, right? Small tasks are better because you can do many tasks at once, and you have a higher throughput. But sometimes you don't. If you do annotation in 1,000 of files, that's not gonna be fast, right? It's gonna take a while. So it will depend how many tasks per minute you are receiving, right? And you have to find a machine or scale this machine to have a response time that you want. So if you have a long task and you receive one task per hour and takes like 40 minutes to do the task, it's one machine is enough, right? So you have to understand your environment to know how many machines do you want to keep the response time in a acceptable way.
Right. There's the next question starts with a thank you note about formatting the code in presentations.
Yes. That's a very fun. It's a glad I found that. It makes the presentation much better.
Yeah, and but the question in itself is, can we have problems with scalability? Can we add more workers to subscribe the same messages? And what resource issues could we have?
You can have that, but will depend on the broker, right? So RabbitMQ and Kafka, for example, you can have a lot of consumers inside of the same queue. So you can have like the topic Kafkas have partitions. You have to do this when you create a topic. So you have like 20 partitions. You can have up to 20 process working parallel consume messages. RabbitQ is more flexible. You can just add consumers as you go, and there is no limit for that. But you can reach RabbitMQ has a small problem that if the queue grows a lot or some other queues grows a lot, this is everything on the memory. And if you like reach the memory limit of the machine, will crash Rabbit and crash everything. So you need to be aware that the queues must be with the lowest amount of messages possible to not broke the cluster itself. Or you have like a big machines to have a lot of memory to hold everything in memory.
Okay, and one final question. Thank you very much. Knowing how the models are performing when in production is important to monitor if everything is going okay. How would that fit in the architecture that you described? So how would you fit the monitoring?
You can you can monitor with anything, right? It's machines. You can monitoring the CPU usage, the memory usage, network usage. You can monitoring I/O on the disk. You can monitor a lot of things in the same machine, right? So you depend where you are. For example, AWS has CloudWatch, and you can see everything that happens with your machine, right? And at the same time, you can create things like with Datadog, for example, that you can monitoring and create your own metrics. Like every time that I start the machine learning inference and end the machine learning inference, I have a time, and I can send this time for a time series database and monitoring what's happening. So I have like a test that's taking too long, I can send an alarm and see what's happening. So, and the broker and the backend itself are monitorable, right? RabbitMQ has a lot of monitoring tools, a lot of databases. Redis, Postgres has monitoring tools for space and this kind of stuff. So it's nothing new. It's just a way to organize and separate the responsibilities for the API and the machine learning, so you can monitoring them, scale them, and deploy them differently, and not having a problem like have a gigantic GPU machine with a deep learning model doing the same time API requests, but it's taking like 2 or 3 API requests per minute because you have to do a lot of work with the deep learning, right? If you can split them and the API can do thousands of messages per minute, you can have a lot of different deep learning machines dealing with that stress and not having this in the same thing. It's more complicated to scale. You have a lot of machines doing a lot of fewer work, and you can do better organization and control your costs. I think it's better to control the costs like this.
Perfect. Thank you very much, Danielle. Thank you for your presentation. We had good comments. I hope you can follow the rest of the conference. And
yes, I got a review to YouTube to see.
Exactly. Take care. See you
Okay,
later.
thank you.
Thank you.
Bye-bye.
Bye. And I'll put on the clap now. Hi, everyone. We're gonna move straight to our second panelist of the day while I run this. Christina, I'll use some time to make sure that everything's working on your end.
Can you hear me? It says you cannot start screen share while the other participant is sharing.
Yeah, exactly. Thank you. I think we're hearing you. It's all good. I'll stop now, and now you can share. Welcome to CommitPorto'. Thank you for being here. It's a pleasure to have you. And
just start the video as well.
Yes, please.
Yes. Can you see me as well?
Yes, I can.
Yes.
Perfect. All good. Let me just see where my mouse and I've just lost my mouse, which is not so nice. All right, now you should be able to share your screen.
Yes, let's see.
And oops. All right, is it? Oh wait, sorry. I think I might need to remove this pin. Okay. Thank you. I'll mute myself now. Yes.
Yes.
Welcome.
Hi everyone. Welcome to this wonderful Saturday. I'm tuning in from Oslo. It's raining, but I hope the weather in Portugal or whatever you are is great. So my name is Christina, and I will talk to you about a little bit about mobile AR and what we have today, and mostly I focus on Android. Yes, so a little bit about myself. I'm an independent consultant, also an Android and Maps Google developer expert. I have been AR enthusiast for quite some time, since 2011, so many of my friends and colleagues know me as a crazy AR person. And I also started blogging about AR, and in particular AR Core, on my creative tech blog. So anything I refer from my presentation today, you can find there. Agenda for today. So I really want you to have the overview over what you can do with AR and on Android, and what are different options, and what are the things you need to think about. So every one of us, we know what are basic features or that you can look at, but because of my experience, I would say I can tell you a little bit about what you have to think about when you're choosing this or that solution. So I think that might save you a little bit of time, and that's where I focus on this presentation. Let's start with the easiest one. It's Model Viewer. For you, if you're a native mobile developer, we will talk about web development a little bit. So what's the Model Viewer? Model Viewer, it's a web component where you can actually display 3D models, and on top of that, you can make it interactive in AR as well. And now I will show you how we can add a little bit of code and have your models on your web page or your web platform available for others to preview in AR. So here how we start. So you have your web page, you have your e-commerce or something, shop. You have to include the scripts here. And the next is the model viewer, the web component you have to add. And here we are adding astronaut. I will show you later the demo, astronaut model. We give the name and author date and camera controls. This 5 lines of code just gives you 3D preview, doesn't give you AR yet. So let's look how we can create AR view out of the model viewer. We will simply add these 3 lines. AR is like, we just say, okay, enable AR button in the preview, so we can preview in AR. AR scale is auto, and the AR modes as different what we choose. Quick look is for iPhones, and scene viewer is for Androids. And I want to say the model viewer will propose you to view in AR only on mobile phones. And that would be the final result, how it looks. First, you have a preview, and then you can place it in AR. So as you can see, in 5 lines of code, we can easily add AR preview on any of your web pages. So advantages, it's easy to implement. And I think many people don't know this feature, so that's amazing. Android and iOS support. Although, be mindful that not on all Android phones support AR Core. So we need AR Core support to be able to preview on Android phones. Browser support, we have pretty much good coverage. And I think this is perfect for e-commerce, where you have chairs, tables, and so on. What are the disadvantages of this approach? So for both Android and iOS, you will have to provide different types of 3D files. So for iOS or for iPhones, you will have to provide a 3D model in USDZ format. But for Android, it's GLTF format. So that's a little bit of work maybe on your side to provide those 2 models. And limited functionality. So so you can only add 1 animation. You cannot control the model. So what you can do, you can only place it in your living room or wherever you are. So I think from my point of view, it's perfect for e-commerce. Next one, Scene Viewer, also using AR Core. And in this presentation, I will only go into how we can use it from Android apps, from intents, but you can also do the same from web browsers. And you can check documentation about that. So Scene Viewer is the immersive viewer that enables 3D and AR experiences from your website or Android apps. So how we can do this? Here is a little bit of Kotlin Android code. And if you're really interested into dive deep into this this option, I have a blog post, my latest blog post on my blog about that, and I have an open source sample where you can play with different options for how you can trigger different intents and show AR models in AR. So, for example, you have an app, Android app, and you want to implement AR feature, and you don't know where to start. And you have something, you have maybe, let's say, IKEA app where you preview again like sofas and tables. Instead of going into and doing it natively, implementing everything in native code, what you can do is you can call the intent from your Android native code. You can provide, here is the link to the model. It's a duck.gltf. And you also add different parameters like mode. And I say, show me only in AR. You can also do 3D and so on. Title, and you can put it resizable, not resizable. For example, coming back to the IKEA example, if it's a sofa, you don't want it to be resizable. You want it to be a real size. Yeah. And then you simply start the activity, and another app, Scene Viewer, will start and preview your model in AR. So to start using AR in your mobile apps is not that hard if you have a simple use case, but you can always start and see where it leads you to. And then we go into AR Core, into native development, and a little bit more. So when we talk about AR features, I will go and talk a little bit about the challenges about those. So the first one is the oldest feature we can talk about is augmented images. It's when we have a target image and we overlay AR content on top of it. So your phone recognizes the image and it will overlay. The most important thing you have to think about is the image quality. So it doesn't work with all the images, and you have to be mindful of that. If you have a special command to check your images if they're good fit for AR Core or for augmented images, and this is AR Core image eval tool. You can find it in AR Core SDK. So be mindful that the score of 75 and more is the best. Otherwise, your experience will be flaky, it will be moving, it will be not stable, and the user experience will suffer. So I did a little experiment, and here is like 5 images. The best one, if I remember it correctly, it's this one. The worst one is, I think, Scream. It has 0 score. So the AR will not work perfectly there. My favorite feature, augmented faces. Maybe some of you used similar features on Instagram, for instance. What you have to be mindful of is we have a face texture of 478 points. We can also easily get different points on your face and overlay some interesting 3D models and textures. I have several blog posts about augmented faces and several samples on my GitHub, so please check it out. I will not go deep into different examples, but what I want to say is that when you're modeling something in 3D, let's say in Blender, and you want to know if it fits well, what you can do is to download canonical face mesh. It's attached to assets in AR Core SDK, and you put it into Blender and put your models on top of it so you know how it fits. And when you export your models, just disable the model or remove the canonical face mesh. But in this case, it will really help you see how the model fit the face, and you can also scale it correctly. Next one is light estimation. Is very important in AR Core. I will not dive deep into it, but AR Core uses machine learning to estimate the light, and this is one of the amazing results they showed us last year that you almost, in this GIF, you can see when we turn on HDR lighting, you almost cannot see what is virtual, what is real. And that's amazing. And that's one step ahead when we're going to more immersive experiences on AR. As I said, we're using AR Core using ML to estimate the lighting. And they have trained the models on thousands and thousands of images. And what they do, they take a picture with these 3 balls and measure different properties of the sun and different properties. And so they use it, they train the model, and every time you use AR, they estimate, okay, which property, which one it looks like, and which property we should apply to your model. So the model looks real in your environment. And yes, and that's a real, that's the little demonstration on how, what you expect, why light estimation is so important is that we expect the kitty looks a bit darker when it's in the shadow and lighter when it's in the sun. And that's why HDR lighting will be so important. Next one is cloud anchors. I think this is the most underestimated feature in AR Core. Not many people uses it. I think it's amazing, especially for sharing the experience. And I will go a little bit deeper into this. So previously we had AR anchors that will be lifetime of 24 hours. It has changed. I will take it next. So first, one of the features, what is cloud anchors? Cloud anchors gives us the opportunity to share the experiences. Like, you don't have to share the phone to see the same thing. You can use 2 or 3 or 5 different phones. You can enter this cloud anchor number, and then you will join the experience on your phone and interact from your side of view. Especially a good use case is, let's say, viewing 3D models, real estate, and you're in the presentation, you have a table and several people are looking from different angles. So that's one of the use cases. And I just want to demonstrate quickly how easy, so to say, it is to implement. So when we are working with, on every frame, we see what's going on, and we also check when we have a heat test, when we place the model, we also check if we should host it as cloud anchor. And it takes some time for us to save the anchor or to save the experience into the cloud so everyone else can join. So keep that in mind, that it might take up to, let's say, a minute until the others will receive the same experience. Yes, and persistence cloud anchors. In my previous presentation, I was saying that it was in development. I'm very happy to say that as for 3 days ago, AR Core released persistent cloud anchors, which means that soon now we can save our cloud anchors. So you can come back after 3 days and have the same experience in the same place. Yeah, so for example, you can play with your friends, like scavenger hunt. You can go around in the city. You can place some AR thing there. You can ask your friends to find it, and they can find it after several days, weeks, and so on. So you say host cloud anchor with time to live. You can set the time, how long it should live. The time is up to 365 days, so a year. Yes, so I am very excited about this feature. So one of the last things I'm going to talk to is depth API. That is very important, and why it is important. So one of the recent features for the last 3 months was introduced. Let me jump into why it is important. So depth API is solving occlusion problem. Here is our previous preview where we have Android on the floor, but as we move, you can see it's overlapping on the table, although it should be kind of hidden away. So the depth API is solving this problem, and it gives us yet another possibility to create more realistic experiences in AR. Yes, that's another demonstration on why depth API is important. You can see now that this is with depth API and this is without. Next one, another demonstrations. I want to mention there is an app for UI people and for people interested in how to make better UI and experiences in AR core elements. Check it out. Yes, I want to add one of the things. If some of you checked out Cineform and worked with AR, you know there is AR Core and then Cineform. And unfortunately, so Cineform helped us a lot with not going deep into OpenGL. But unfortunately, it got, or fortunately, it got open sourced and unfortunately archived. So now it is on us to develop it further. So as for now, Cineform is 1.17. It doesn't have depth API support. It doesn't have persistent cloud anchor support. Keep that in mind. So what next? Do I have 3 minutes? Yeah. Yes. The main challenge for you guys is, or girls, is what to choose. It's really a challenge. And so when we're going, and I will just take some examples, IKEA Furniture app, model viewer is great, Scene viewer is great, and you can, of course, do it natively as well. Pokemon Go-like app. You need a lot of graphics, you need physics, you need everything. Check out Unity and AR Core, great support. Also, there is AR Foundation that is supporting both AR Core and AR Kit. Unreal Engine as well supports AR Core. AR is existing native app, AR Core, Android SDK. You will have to be good friends with OpenGL, so keep that in mind. Shaders as well. You can also do Unity widget. That's very also exciting. And there is one pretty good tutorial about Unity widget and Flutter for Flutter enthusiasts. Check it out. And experimenting and prototyping, I think Unity is very fast and you don't need to have a lot of knowledge about computer graphics. Recommending. Cineform is also great for prototyping. Keep in mind depth API and the new features are not available there, but still great and very easy and fast. And that's me. I think you have probably a lot of questions, as do I, but I'm happy to answer.
Thank you very much, Christina. I will, before we go into the questions, our team, the alumni, is collecting and preparing that for me to ask you. And so I'll just share my screen and gonna do one promotional video from one of our sponsors. It will be a quick one, and then we'll move into the questions. So let's see if this I can get this first time this time. Oh, Jesus. I had to miss it. Sorry. And that's it. Thank you, Darwin, for sponsoring us. And apologize to everyone for having missed it the first time. But, too many buttons to click, and I'm still getting used to this. So, Christina, thank you very much again for your presentation. I will just highlight again what you mentioned, that you have your own blog where people can also find some of these materials and some articles from you. So everyone after the conference should make sure to check it and follow up on what else Christina is working on. So the first question is a bit, I think, about your opinion, I guess, about AR in general. So apart from social networks and e-commerce, where we already see frequent applications, what other areas of society do you see this type of technology being more and more used in?
Yeah, so yes, on the general side, I can start that I believe that we will get glasses at some point. I don't know when, but we will. And so e-commerce, of course, I think it's big. I believe also education and real estate, from my point of view, are the bigger one as well, bigger players, as well as entertainment for like something like Pokemon Go. I think we'll see more kind of play gamification kind of style games and yeah, experiences.
Yeah, thank you. Yeah, I do actually play Pokemon Go, so I can relate. So, in terms of like the performance of AR, what is the component that has the biggest effect? Is it the CPU, the GPU, or the camera on the devices?
It's really hard to say, but I mean, the GPU, I think it's very important. And as you know, not many devices supports AR Core, and also on iPhones, not all the phones support ARKit. So that's definitely also a hardware issue. So I would say GPU and then CPU, and then a camera is not that important, because even for machine learning, we don't need this high resolution. Like machine learning, when we use like depth API or light estimation, we don't need high resolution like image. We need only like, let's say 400 pixels. So that would be enough, I would say. So the camera, I think, is the last one to come.
Okay.
Yeah.
Okay, so the Android ecosystem is composed of multiple different devices, some with 3 good cameras, some with just 1 bad camera. How do you deal with this? But actually, maybe you just answered this, but how do you deal with this? Is there any assumptions that you can make regarding minimum camera quality, or because it doesn't really matter, so maybe any camera?
Yeah, the camera doesn't, I would say the camera itself, as we think about it, doesn't matter, but what matters is the GPUs and what it uses inside. And of course, AR Core has some requirements on what kind of chips it's running on. So there is, if you Google AR Core supported devices, for example, you can check out what devices they are supporting and check out what they have. But even like today I checked Samsung S10, that is not like the most powerful phone. It supports AR Core, and it's also quite old. So I would say, I would assume most of the phones you buy these days will support AR Core. Although also keep in mind, there is one thing, the Huawei phones, there is currently this HMS ecosystem they have. They have been doing a lot of work to support AR Core-like experiences. So they have their own kit, HMS kit, that supports also augmented faces. They support a lot of things. So keep that in mind as well when you, let's say, want to do AR Core only, and then keep in mind that maybe if you buy a Huawei phone, you have to do HMS Core and not AR Core.
Okay.
Yes.
So I think that's one that I think is a bit repeated, is about the uses of AR on mobile, but I think you kind of answered that on the previous one. so regarding the SDKs that you mentioned, some other software, are these open source, or are there any good open source alternatives that
There are many. So when we talk about mobile, there are many other frameworks and SDKs, and I cannot mention everyone, but most of them you have to pay for. So let's say Vuforia and Wikitude, you have to pay a license. And that's why I've done also experiences on these platforms, on these SDKs, and the experience is great. But for me, the thing that I have to pay for it, it's the license, although it's great experience. Then AR Foundation, if you're going Unity, I think you would consider AR Foundation. That will make experience for both iPhones and Androids, and then AR Core, ARKit support at the same time. That's open source, supported by Unity. Well, I would not say it's open source, but it's free. I cannot say, I don't remember if it's open source, but AR Core, it's free. If it's open, so Cineform is open source, but AR Core is not open source. So, but it's free.
it's good enough sometimes.
And like all APIs on the maps, like maps, for example, it's like we can use it for free, but it's not open source, you know. So yeah.
All right. I think this was one of the one last one, which is actually regarding these hardware constraints that we discussed. It seems to be a hot topic, and but how does this affect like the development experience of AR in mobile, or it doesn't really affect it? So I guess because you have to deal with all of this kind of what is supported on each phone, is this a struggle, or is just a standard struggle to any mobile development in a way?
So it's also, I think so first of all, it depends on if AR is like important. So let's say if your app will not work without AR, then this app will not be installed on the devices that doesn't support AR Core. And that's one of the things you can write in your manifest, let's say in Android, that AR required, then you will not be able to install the app. The next step is AR like optional, and then what you can do, you can first have like different buttons if you want to enable or not enable AR. So you can check, is my phone supporting AR Core or AR Experience? And then if it does, then you show the button for AR. If it doesn't, you don't. So it all depends on, is AR optional in your app or is it required? And that solves kind of differently.
All right. That was our last question. Thank you very much for joining us today, Christina. Yes. I hope it was good for you. And again, Christina has a blog. Everyone, make sure you follow it. And
also like on Twitter, if you have any questions, please ask me. I always answer people who are curious about AR. Yes.
Perfect. Thank you very much.
Thank you.
Feel free to continue following our conference.
Yes.
And we'll see you another time.
Thank you so much.
Bye.
Bye.
I will now move on to our first giveaway. And let me see if I don't ruin this. Before we move into our next speaker, we do have a giveaway going on. Well, actually 3 giveaways of 100 euros each in Amazon gift cards. If you missed it, to be able to win this, to qualify, you have to write in your questions on Slido. My colleagues from Alumni have been posting the link on the chat, and you can also find it on the CommitPorto'. There's a code to go with it, which I believe, if I'm not mistaken, the info I have is X157, just so you get into the event. And for our first winner of today's giveaway, didn't bring my drum kit, but I will say that his name is Fabio Oliveira. Well done, Fabio. Congratulations, and thank you for contributing, and thank you everyone for contributing. There was actually a question earlier on about the questions asked on Slido. We cannot ask all the questions, You can vote the ones you find are the most interesting ones, so that we pick those to ask our speakers. But sadly, we cannot ask them all. But we'll make sure that we collect the questions that we haven't, all the questions, and send them to the speakers later on for their information. So thanks everyone for taking part in this. Congratulations, Fabio Oliveira. I do hope there's not a lot of Fabio Oliveiras, but our organization will find you. And next up, we will have our next speaker joining us right now. And I just need to juggle Zoom a little. And Jaime, welcome to CommitPorto'. Hi, Jaime.
Hello.
Hello. Welcome.
Good morning.
Thank you for being here. Thank you for joining us. Sorry, we're a few minutes behind, but I think it was for good purpose of questions. So you can start straight away. You can share your screen. I'll mute myself, so I won't disturb you. And thank you for being here.
I'm very happy to be here. And I'm going to share my screen. No, not this share.
That's it. You're
good.
On. You're live.
Awesome. Well, I'm very happy to be here. Very happy to be part of this. It's actually my first online event that I'm speaking, so it's well organized. So kudos to the team, and thanks for inviting me. I'm Jaime Jorge. I'm CEO and co-founder of Codacy. And what better way to spend a Saturday afternoon, talking about static code analysis. I hope to make this interesting to you. And we'll go through some of these topics. I only have 20 minutes and I have a little bit of content to cover. And yes, let's start. So to motivate you a little bit to think about static code analysis, I want to show you a little bit of a stat from a research that Stripe did a few years ago that showed that almost half of the time that the developer is spending working is actually maintaining code. And so that's going to be a percentage between bad code that needs to be refactored, changed, corrected, fixed, or technical debt, which will be problems that you'll have to maintain, things that you also have to refactor, functionality you have to change, and all of those beautiful things that you have to do. And so static analysis plays a role here because it can help you, especially on the bad code side, in identifying code smells and problems that you have to correct and maintain, but also on the technical debt side. And so yeah, it's almost half of the industry is maintaining code. And so if we can build tools that we can help that part of a significant part of time spent in maintaining code, it's very relevant. But let's start with this question. What is static code analysis? Well, static code analysis is everything that involves analyzing code without running it. So it corresponds to the first parts of compilers. So that's the lexicographic analysis as well as the synthetic analysis that gives you issues, problems, that gives you insights without running the code. And 20 years ago, static analysis started really as a way to compensate for gaps in compilers. The same way you'd buy a compiler off the shelf, right? You go to Pinduoduo and you buy a C compiler. You could also buy a package of software that would analyze your code and tell you bugs. And so that's really what happened over time. And so with the advent though of open source, static analysis started shifting more from a commercial nature. They were very expensive, and some still are today, to become actually free. And what happened really was developers, instead of just buying code analysis, because they started getting their compilers open source, they started building their tools, their static analysis tools, also open source. And so linters, as we call them today, started appearing because people said, I built this tool that every time I do this problem that is very repeated in this particular language, it starts identifying these things to me. And so fast forward to today, we actually have a very large number of open source tools that analyze code for you. And they actually largely outweigh the number of commercial tools. This is just a small sample of the tools that are available today. It might be already not updated because this evolves almost every week. But there's a democratization and explosion number of static analysis tools, simple ones, very particular and kind of fragmented in their particular use cases, but a lot of them, right? So for every language that you can program today, chances are you'll have a few linters available to you. And if we start analyzing kind of what they have in common, not only the commercial tools that have closed source, so it's harder to identify, but more from the open source tools, they have a number of shared interesting properties. Number one, they're very configurable. And so they not only, you can, for example, have configuration properties that tell you analyze certain folders, don't analyze certain folders, don't analyze my .git folder, for example, but also focus your attention on these particular types of your language specifications, right? So if you're talking about JavaScript, which is a world by itself, I want just to analyze Node, right? And so ESLint is very known for that, has a wonderful configuration capability, and adapts to whatever software environment you have. Second is the extensibility. So not only tools came with a static set of rules, but also are extensible over time. Again, ESLint is very known for that. You have tools for, and you have plugins to analyze everything, and you can actually extend the tool very, very broadly. And last but not least is really the integration. So you can integrate these tools in many more parts of your ecosystem, of your kind of tool chain, if you will. So you can connect them with GitHub, you can connect them with your continuous integration, you can connect them with even sometimes monitoring, if that makes sense, with your IDEs, obviously, as well. So there's a whole thing that you could do today. There's things like language servers that were kind of the beginning for unified API to integrate tools and static analysis tools, particularly into the ecosystem. And I think as we see and as we go forward into the future, this will be more and more and more important. I think this plays into another part of what we see in the DevOps ecosystem, which is consolidation. So tools are more and more becoming one, and so solutions tend to have lots of value. And I think this kind of plays well into that theme. And then last but not least, tools would not be enough if they only tell us that we're incompetent. Some tools also are able to automatically fix the issues that they find. And I think more and more we're going to that stage. So if you think about code style, 4 years ago in Codacy, we had a great business of identifying problems related to code style because they were very relevant. Fast forward to today, those are automatically fixed, right? And so that's a really interesting thing that the industry is doing. So whatever teammate that you have in your company that is actually producing software and doesn't really care about code style, now you have tools that automatically refactor. For instance, in Go, we have GoFactor, and you have a few other tools that can make your code pretty or uniform or standardized, if you will. So I mean, these are some of the 4 standard properties that you'll find today in static analysis tools, and kind of give you a little bit of sense of what you should expect when you start playing with them. So talk a little bit about the history, a little bit about what we find today. I want to give a few ideas of what we should expect from the future. As we think about static code analysis, it really rose in popularity because it aimed to cover for gaps in compiler design, for problems that we would find over and over again, for pain points that developers would have. An example is Java's null pointer exception. So that was very painful for developers, and it still is. Obviously, we have tons of frameworks and mechanisms to handle this. But my point is that because of that, new programming languages that derived or were evolved from Java's decisions handled this in, I would say, a more sophisticated manner. I wouldn't say better, I would say it's more sophisticated. So you think about Kotlin, you think about Scala, they have a much higher understanding of that decision in terms of language design. And so what I'm trying to get to is new programming languages that will arise in the next 5-10 years will also mitigate flows in static code analysis. So if you think about static code analysis as kind of the edge of identifying problems in front of language design, it kind of just moves forward, right? And so yeah, programming languages will continue to evolve, but so will static code analysis. Second point is tools will learn problems and automatically either recommend or even fix. And a case in point is Facebook Get a Fix. Facebook's Get a Fix, something released a few years ago that automatically learns from bugs fixed in your Git history and suggests fixes based on that. And so this plays into the architecture, very simple architecture that we just demonstrated of plugins and extensibility and the auto fix part. And we think that tools over time will learn from our mistakes, and static code analysis will be infinitely customized, right? So even to a developer's own style or own problems that he tends to create, identify, and whatever. So I think this will also be a trend. This is a trend that is already in place. There's tons of tools today that use machine learning and AI techniques to identify problems. There's a lot of focus obviously on security. Security is a great problem in the static analysis world. And so obviously much more focus on that. But I think over time, like Facebook, there will be more and more tools. Tools will develop APIs, and this plays into what I described earlier. And language servers will be something that will be even more common in the future. So full integration with our ecosystem will continue to be even better. If you think about GitHub, for example, they released a number of important things just over the last 2 weeks, but also over the last year. So they released, for example, the super linter, which is something that we also do in Codacy, and we have more integration with more tools. But they also released a way to integrate other tools into GitHub. And so this plays again the idea of consolidation that is very important and is just happening in the market. And so where does static code analysis play in the DevOps ecosystem? So it tends to play in the much earlier phases of the developer lifecycle, right? And what we see is that in the macro trend of shift of quality and security shifting left, static code analysis plays in a very important part in helping developers identify problems and bugs and security issues as early as possible, because and you know this is much harder and more costly to identify and correct them later on. And so I want to motivate you a little bit to think about the last point of this talk, which is how do large distributed teams do static code analysis? So we're talking about the atom, which is a developer finding issues. We talk about the history today, a little bit of the future. And now we talk about a context of a company. How do they actually do static code analysis? Well, they play, if you think about static code analysis as a set of standards, a set of rules that you should be following, not only code style, but also best practices, basic security, that becomes kind of a standard for a company. And different companies have different types of standards. But what we find, and we find this in our company, is that when you don't have standards, when you have every single developer or team developing with different types of criteria, again, style, best practices, basic security, that decreases performance and go to market. And why? Because it's much harder for you to exchange projects and for teams to communicate. Let's say that this is a company and this is the different teams, right? If this was not a company and this was a product and this was different parts of the product, right? This is the building functionality, this is the user management, and this is, basic semantic functionality for your product. And all of these have different styles and standards. It's very hard for these teams to operate together because they don't understand each other's code. And code is meant to be read and not just meant to be written. Written once, read infinitely, right? And what static analysis does is really helps to enable standardization. So instead of having three teams, three different code bases, three different styles, static analysis can help you standardize things. So interoperability, efficiency, and decreasing complexity, all really nice business words, but that play a really important part in everyday development. So as we think about standardization the old school way, we think about requirements, verification, implementation, and maintenance. And then we would think about, okay, we'll just, when we're testing the whole product, we'll make it standardized at the later stages because that's not really important. It was the same thing with testing, and now we're doing continuous integration. Same thing with static code analysis, and the same reasoning has created a movement to shift left security. And obviously, as I motivated, less money, less time, less bicep strength. There's all of these things that are less important when you not standardize. And how we see things happening today is that high performance teams that can ship code faster and better code, and code is easier to maintain for future generations of developers, they do it earlier. And they do it when they're coding and when they're building and when they're putting code in GitHub and when they're coding with their teams, and it's really continuous. So instead of you having to think about standardization as something, okay, so we're going to deploy now, or we're testing now before things go into production, it should be done consistently and continuously. And this is what we find is that the teams that actually do this have, it's much easier to then maintain code over time. They get to find problems much earlier. And we as a product, Codacy helps with that. So that's it. That's an important part. So this is a bet that I made 2 years ago. So it's already not updated, unfortunately. And I see that this is actually much more real than it was. So it's much more obvious now. It is actually more real than it was 5 years ago. But static analysis will be as important and pervasive as build tools. And this is already reality, right? So you don't think about static analysis when you're actually using a linter within your IDE. It's just there. You don't think about static analysis when you have, tools, whether from Codacy or other tools, giving you insights inside GitHub, GitLab, Bitbucket, right? It's just there. It's just almost like an intelligence. So I think it will continue to grow in terms of adoption, in terms of pervasiveness, to the point that we don't even think about them. And that's a really cool thing. Yeah. Well, that's my presentation. I'm really happy to show you this. Thanks for organizing Commit. Follow me on Twitter. And if you have any questions, let me know.
Thank you very much, Jaime. It was very nice. I'm a very big fan of static code analysis in general. I think it's kind of really important for the sanity of development. But before we go into our audience's questions, I'm just going to play a short video from one of our sponsors, and I'll get back to you in a moment. I'm going to take over the screen now. Now back to Jaime. I hope this was enough time. It's a little shorter. Thanks again to our sponsors for making CommitPorto' possible and for helping us. Again, it's been a few years, so it's been always awesome. And it's a pleasure for me to have them in my background and sometimes on my face and my hands. It's all good. So to start off with some questions, and that came from our audience. So the first one is, how reliable do you think static code analysis is? Is it, if it is well prepared and set up, is it possible to be a filter for any vulnerability and error? What are your thoughts?
So it really, that answer really, I mean, we support more than 30 code analysis tools and more than 30 programming languages in Codacy, and that experience has taught me that it really depends. Unfortunately, it's not a clear answer. It depends on programming language. It depends on the tool itself. Depends on technique of static code analysis. What I would say is that static code analysis is very prone to have false positives, because if you think about a compiler, it is just the earlier phase of compiler of the compiler. So that's it goes up to its synthetic analysis, and so it tends to find, it's good at finding things fast and predictably, it's harder to find kind of other problems like SQL injections and things like that, because you need different techniques to do that, right? So you will need dynamic and runtime code analysis, the dependency tracking. You will need data flow analysis as well, and you can only do that with more advanced techniques. And you think about, let's say, the advent of machine learning and AI techniques, that will be also something that could be applied on top of that. But I think they're very good at finding consistently the thousands of easy problems that you have in your code, and that you need to find every time.
All right, thank you. Makes sense. So when we're dealing with languages that are not typed or don't have static typing, what are the limits and things what are the limits to the things that we can do? Or are there things that are impossible that other languages provide? Or is this where actually this is me adding to it, if it's where actually the static code analysis brings more, because the statically typed might have stuff caught on a compilation when they're running? What do you think?
There's people that say that not only so if you think about error handling and things that are kind of techniques that developers use to kind of fortify their code, there's people that say, and this is a big war, and it's very hard to just go into one of these wars in YouTube, but I would say that there's the typed and non-typed, so dynamically typed or typed languages. There's people that say that static analysis is even more useful to dynamically typed languages, because you don't have many times the safety of types and a few more kind of guiding rules that could help you identify problems. At the end of the day, this is my view of the world. I want to have as much safety as I can when I'm writing code. I want to be known. I want to know all the problems, all the ways that I'm stupid before code goes into production. And so if I have a tool that identifies that, if a compiler tells me that, great. If I have a tool that identifies that, great. So that's that. Yeah.
All right. So you mentioned that, and I apologize, I'm going in order, so maybe sometimes I'm going to be jumping between topics, but there's quite a lot of questions, so bear with me. You mentioned there is a trend to add the AI to static code analysis tools, which might raise security concerns. Can you give us a little more info into this issue? What are the major security problems and possible solutions to tackle this?
Well, this is interesting. We've learned the hard way in our company that code is many times one of the most critical parts of an organization. I think as organizations evolve, they see that actually is people and not code. But what we find is that code is really protected, right? So for many organizations. And because of that, what we had to do in our organization was to provide two ways of using our product. One is our cloud version, so that's codis.com, and that's an on-prem version. And so what I'm getting to here is that there's a need to have code protected. So yes, there's an IP problem there, and companies want to have these tools that touch the very critical part of their IP as close to their chest and heart as possible. So, but this is one of the reasons why you have GitHub offering on-prem, why we offer on-prem, GitLab on-prem, because they can't share. So if there's ways that we can apply those techniques without calling home or without having other people looking at code, it is a way that we can operate.
All right. So how do you suggest that one can deal with the high number of false positives sometimes produced by static analysis tools?
This is a very difficult problem. It's a very good question. We've been asking ourselves this from the beginning since we created the company. We still don't have a perfect solution. There's no silver bullet for this. Well, we find that there's a set of things that work well. First and foremost, you need to be patient and maintain your tools. So what this means is the configuration part of the architecture that I mentioned, you need to continuously review that. So let's say that you adopt a set of configuration for your code analysis. I like these rules. I like my line length to be at 80 characters. Great, you put that in configuration. Now you have a new team member, someone that is working on your project or a person that was hired, and you need to adapt those rules to the new team member, right? So maybe that person will want to have more 100 characters. And why is this an issue? Because there will be a conflict whenever code gets checked in GitHub. And so maintenance, constant and continuous maintenance of your configuration is very important. The second part is don't live with broken windows. So if you have consistently and continuously false positives on things that are annoying to you, don't let it be. Don't let it just continues to be flagged. Don't let it be warned. Tackle that and say, well, I don't use this rule anymore, therefore I should disable it, right? And last but not least, and just to puxar a brasa à minha sardinha, as we say in Portuguese, what we do in Codacy is we have a few mechanisms that you can ignore the rule, ignore the file, and so it over time it adapts really well to you. And we have a really good set of defaults as well, which helps you to use all of these tools at once. So centralization of these tools instead of having to manage one by one is really helpful as well.
And this brings me, there's actually two questions that I think are mostly the same. What are do you see any disadvantages, and what are the biggest disadvantages or drawbacks? Maybe, yeah, drawbacks a bit lighter than disadvantages to using static code analysis. Besides this, and I would add to this, but I think it's a bit related, like how many, do you have any statistics on people that use Codacy that will do, I don't know the name, well, what would be the flag in your tool, but like no verify, like skip the rules. Do you track those kind of things, you know? And is that the drawback, that people can get like give up on fixing the issues brought up by static code analysis?
I think the disadvantages is one thing that we mentioned. It's if not well managed and organized, the noise to signal ratio could be very bad, right? So it could tell you things that are not meaningful, and then over time, exactly that, no verified. So I will just ignore that and just bypass it, and just in one, it goes to a conversation. You implement static code analysis, but you don't put the effort to kind of organize it, put it properly, talking with people like what's our code style they want to have in the organization, what are the rules they want to enforce. And over time it just becomes a nuisance, and then there's another meeting at the end saying, why do we really need this? No, this is everyone put them in the IDs. So the clear disadvantage is really the noise to signal ratio. It could be low if it's not been well. And what we find in Codacy really depends on organization. We find that in Codacy that every organization has a team structure of kind of the best performers, or the people that, not that best performers, I don't want to classify them the way, but the people that are always cleaning the code. They're very pedantic. They're kind of guiding, defending the walls against things, and if there's problems, they're there cleaning code, and they're helping every time. There's people that are very fast to ship code, and they get very annoyed by things that drag them down and say, static analysis, I don't care, that's for someone else, not for me. And there's a natural tension, right? Because people want to do things well, some people want to do things fast, and static analysis tends to be more liked by the people that are very specific and want to do things really well. And so what we find is that the no verify tends to be when you want to ship things. But like technical debt, and we all know that, it accrues over time. So if you don't care about the problems that static analysis find, even if 60% of them are false positive, you will also accrue some problems in your code base. They will have to maintain in the future.
How well do you think that the static code analysis scale in big projects? Is there any relation to, as the project grows, people stop doing it or become more broader, or actually it's better because then you're more secure and confident of what you're doing and you just get used to doing it? What are your thoughts?
If this question was asked 5 years ago, I would say that you need a whole organization with one instance of code analysis, and that would be great. But what I find today is that it's a divide and conquer problem. There's teams within, let's say, an organization, a large organization. There's teams that want to really care about static analysis because they are developing mission critical software. They're developing software that they want to be broken, that is very important for the team to collaborate really well. So style, for example, a best practice as basic security is very important. So static analysis is obvious that team has to use. And maybe there's another team that doesn't have all those requirements, but has a really important deadline to hit, and they will kind of skip some of those phases. What I find is that over time, the whole organization will be motivated to do that, but that will be pushed from developer managers and then the VPs and the directors to kind of use across the board. But it's difficult, and I think it's if an organization is a tree, then all the leaves are part of getting static analysis on board and standardized. This has been the challenge that we have. This is a problem that we try to fix for our company, is how do we enable companies to have one unified view of static analysis across the board for all developers, so that we ship code consistently with the same criteria. So that's our kind of view of development.
And thank you. And this brings me to the last question we have, which well, we kind of answered, I guess. But do you use Codacy to do static code analysis at Codacy?
We do. You know, this is a really good question. We in the very beginning, we were kind of it's not eating your own dog food, is drinking your own champagne. I like that expression better. And I think what we started discovering is that, well, we actually need more. We want to not only to know static analysis, but we want to know code coverage. Is it decreasing? Is it increasing? And so we put that feature in. What about code duplication? I want to have view of all the duplicate code that I have. We put also that metric in. So because we were using our own product, we started getting more and more feedback internally. So yes, we do use Codacy to build Codacy.
Awesome. So Jaime, thank you very much. It's been a pleasure to have you. Thank you for all your answers, and I hope you can stay tuned in the afternoon. And take care, and see you next time.
Thanks for inviting me. It was wonderful to be here.
All right. So before we close off for lunch, and this time lunch won't be provided by the organization. Apologies for that. I also suffer, but we'll have 2 hours break in a bit, actually. So we'll be back. We'd like to be back here at 2:25, so p.m. Portugal time, which I think is GMT +1. For anyone following us outside of this time zone, it's been a real pleasure being here this morning. Thank you to all the speakers we had. Congratulations again to Fabio Oliveira for winning the first giveaway. We'll have 2 more in the afternoon, and that's it. Don't forget, we'll be on the same YouTube link. You'll have to ask questions on Slido if you want to win the giveaway. Thanks to our sponsors again, and well done to, if I may say, to the alumni team behind CommitPorto'. I think it's going well, and I hope everyone is enjoying. See you in the afternoon. Enjoy your lunch and take care. Good afternoon, everyone. We're preparing to resume CommitPorto'. Wait. Why is this? And we'll start the next talk at 2:30 Portuguese time, which is in 15 minutes. And in the meanwhile, make yourself at home, grab some coffee or water, something, which we would gladly provide if we were all in the same location. But we aren't. That's okay. Okay, I hope I'll master this. Swapping between windows and presentations soon. I hope everyone has had a awesome lunch or breakfast, depending on your time zone, and that you are all energized, had some coffee, and ready to ask some questions. As you know, if you joined us this morning or if you've been following us on social media, we're doing 2 more giveaways this afternoon for the best questions asked to our speakers. So just help us make this conference even better and ask cool questions and get the chance of winning €100 in an Amazon gift card. These questions need to be asked via the Slido URL that is available on our website, and you need a code to get into the event of CommitPorto, and the code is X157. So take note, get into it, and write some questions. You can vote on each other's questions and help us pick the most interesting ones to ask to our speakers. We're close to start time. I want to thank again to our sponsors that make CommitPorto possible. As I said before, we have Bit by Sun IMC, OutSystems, Critical TechWorks, Narwin, and also Digital Lab supporting us. And we always partner. So we are, well, I can use the time to say and remind you that we are, or the organization of CommitPorto is the Alumni Association of Informatics Engineering or Software Engineering at the Faculty of Engineering in the University of Porto. And we've been organizing, this is the 6th edition of CommitPorto, the first fully remote online version. We are enjoying this ride. It's been a bit different, but it's going well, I think. But we do miss being in the same space and getting a chance to talk with you guys in the coffee breaks and at lunchtime. So hopefully next year we'll be able to be back doing it live in wherever, probably, well, for sure in Porto, but location and venues might vary, depends on the organization. If you have a company and want to sponsor CommitPorto 2021, reach out to someone from the organization. No need to do it just yet, but for sure we'd like to count with the support of our companies in Portugal and Porto and anywhere, really. What else can I say? We're almost there. We have already a few people in the chat. Hi everyone. I do have everyone live on my phone. Very proud of my setup here. 2 laptops and 1 phone. 4 screens between everything. So a bit crazy, but also fun. Makes me feel like I'm a radio host. There's a suggestion on the chat for next year to have bigger coffee breaks. I don't know if that's a good idea. more talking than discussing tech, or maybe more discussion of tech. Our next presentation, I can start easing into the introduction, which should. I'm very good at this. Yeah, so next, she's already on the backstage of our Zoom webinar, but I'll invite her over in a moment. But our first presentation this afternoon is going to be Elizabeth Oliveira. And you can access Slido to ask questions using this QR code on the bottom right of the slide that you're seeing on your screens, or just follow the link that it's also on our website, so CommitPorto'.com. We are also tweeting and I think writing on Instagram and Facebook potentially. So if you want to leave comments there, I also appreciate it. And you can retweet and share and all of those things that people do on social media when they like stuff, because spreading the word is nice. Sharing is caring. And I always underestimate the time thing, or overestimate the time things take to say. And I already said all the things that I have to say. I should bring jokes to share with you guys, but I kind of forgot. Oh, Angel, I can say that. You want to know what latest technologies I am using? Well, in my company, but it shouldn't be a promotional of my company. That would be bad. But it's basically Python and Django, if you want to know. So Angel is going to be our second speaker this afternoon. So he's already in our feed, in our chat. So say hi to him if you want. So like this morning, the presentations are going to be 20 minutes, and then we have 5 to 10 minutes for the questions, and we have a few promotional videos from our sponsors that go in between the presentation and the Q&A that I'll run from my end. So this allows us time to verify which questions have more votes and ask those. All right. Thank you, Angel. I don't know if, still 7 minutes to start. Time flies when when you're talking from thin air, it seems. So, well, it should. And there was a suggestion earlier for me to put some music on while I waited, and I thought, nah, we don't need any music. I can speak endlessly. It seems that's not absolutely right. So I'll get some tunes in. While we wait. Any requests from our audience? Let's go with this. Pois eu não tive a noção do seu fim. Pelo que eu So when so there was a question on YouTube about who are the 11 for the next match, because once I did have to fill in some time and there was a match about to happen. That's not the case today. So I don't know if you can listen. Can you hear the music, or is it just me? Thank you. So I'll shut up.
Tantos planos para depois. Fui eu quem virou as páginas na pressa de chegar até nós, sem tirar das palavras seu cruel sentido. Sobre a razão estar cega, resta-me apenas uma razão. Dia vais ser tu e homem como tu, como eu não fui. Dia vou-te ouvir dizer que pudesse eu pagar de outra forma, que pudesse eu pagar de outra forma, e pudesse eu pagar de outra forma. Sei que dia vais dizer
All right, welcome back. I hope you enjoyed a bit of Ornatos Violeta, an awesome band from Portugal that I particularly like very much. And there's 2 minutes to go, and I'm gonna ask Elizabeth. I know she's on the YouTube feed and the chat, and maybe she can join in and say hi and get everything set up for our presentation. Welcome to CommitPorto', Elizabeth.
Hello.
How are you?
Yeah, I'm good. Good weather in Lisbon, so perfect.
It's the lovely summer of October. It's coming back. So I think if you want to put up your slides, start the screen share, and we can then start on the dot.
Cool. So can you see this?
Yeah, it's
Okay, cool.
so good. So 1 more minute and we'll be ready to go. Thanks everyone that has already joined. Once again, I'll repeat myself. Ask your questions on Slido to make our conference better, but also to have the chance to win one gift card from Amazon. We have 2 for this afternoon. And I will shut up soon to give the stage to Elizabeth. All right, there we go. Welcome to CommitPorto'. The stage is yours.
Okay, thank you. So hello everyone. So today I'm going to talk about building a Markdown editor, but from a design perspective. First of all, I want to say that it's really a pleasure to be here and to be a part of CommitPorto' 2020. Who am I? My name is Elizabeth Oliveira, so I'm Portuguese. from Lisbon. I lived a few years in Dublin, and I worked for a few Portuguese companies, then a few companies in Ireland, in Dublin, and then I moved back to Portugal because now I'm working remotely for Elastic. So basically, at Elastic, I'm a senior product designer, and part of my work is to build the Elastic UI. There is like a design system, and I'm also building the Kibana. And this is my Twitter handle, MilkyMio, if you want to follow. I like to share a lot of things related with music, and also sometimes I share things that I do at work and personal projects. So this is where I work. I work at Elastic. Probably not sure if you heard about, but Elastic started with Elasticsearch, and a lot of companies use Elasticsearch to create their search. Like if you're on Netflix, Uber, or Slack, probably you're using Elasticsearch. Twilio, Microsoft also are our clients. And this project started like an open source, and then it evolved, and today we have like 3 different solutions that you can use it at Elastic Cloud, like enterprise search, observability, security, and then you all of these solutions are powered by our stack that is made of Kibana, Elasticsearch, Bits, and Logstash, and then you can deploy everywhere. So as I said before, I work for building the Kibana. Basically, Kibana is like a UI where you can manage all of your solutions. And I also work for Elastic UI, and Elastic UI is our design system. Both Elastic UI and Kibana are like open source projects. It means all of the code are like available on GitHub, and you can contribute, you can use for your projects. And it's really cool because everything we do, it's like public there. So today I decided to talk about how I built a Markdown editor, and one of the ideas of the CommitPorto' is to bring together the professionals who tackle challenges in software development. So I thought this could be a great opportunity to show how I tackle projects at Elastic, but from a design perspective, who also does code, because I also do code. So I can show you like how we build that, and then you also can comment how we, mostly I think today we will have like engineers, but you can also comment on in our chat how you work with other designers at your company, in your teams, and if you were building this Markdown editor, how your team was going to do that. So you can also share the way you were going to do that, and you can see how we work at Elastic. Just to say that at Elastic, we work distributed. My team is mostly at United States. I'm the only one in Europe. And even inside Elastic, different teams work in different ways. And we are more than 1,000 people working together. But my team is very small. We are only 7. And then building the design system to feed all the company, sometimes it challenges. So you can see how we do that, how we prioritize what you can see the way we pick what is going to be like the next component to our design system. So just to see how everything starts, mostly it starts like with an issue in our GitHub repo. And to build that Markdown editor, everything started with one colleague of mine that is also part of Elastic. It's not working for Kibana, but it's working for other projects. And one day he went to our repo at Elastic UI, and he said that he wanted something very similar to the GitHub Markdown editor. And this was at the beginning of 2019 in January. And the issue stayed there forever. You know, we have a lot of issues, bugs, and it stayed there. I think no one answered him. And it's not a good thing to do, but almost 1 year after, in December of 2019, another colleague of mine, also working for Elastic, but for another project, he went to our repo and he said, oh, we are building a Markdown editor, but this Markdown editor is for a project inside Elastic. And he said, if you want, I can create a pull request with this Markdown editor. My team decided that it was like a good idea, and we said to Ian, yes, just to open a pull request, and then we can take over your pull request, clean up the design and accessibility, and make it like available as a component inside Elastic UI. So, but first of all, we're like, do we really want to build this? Do we really need a Markdown editor inside our design system, the Elastic UI? So as a team, we had a meeting and we decided, okay, if you're going to build this, first we have to define what we want to build. So we decided to say, okay, this is what we want to do. We want like a Markdown editor that is easy to write, easy to read as a plain text, and we know that the content could contain code, images, attached files, or even like embeddable components. And we didn't want just to copy the GitHub Markdown editor or other Markdown editor. We wanted to create something very specific. So we knew that for our consumers, that basically is people from Kibana, if they wanted to use this Markdown editor, we needed this part. There is like the embeddable components. So inside our team, that we are 7, we defined who were going to work building the Markdown editor. So Dave is like our like manager, and he became like the project manager, and he's very good and also American, so he knows how to write English. So he was responsible for the documentation, and I was responsible to create the design and also to implement the design, but just like the UI. And then Chandler, there is also from the United States, he was responsible for creating like the API, and his role was the tech lead and primary engineer. And Caroline was responsible for the quality management and also to do the review of the code. So, okay, we defined the team, and then we said, okay, so let's create now a roadmap. And so we divided the roadmap in 5 phases. The first one was just like, for me as a designer, to discover, design, and do some research. Then we wanted to agree on a feature spec and start creating a early design proof of concept. And then the phase 3 was basically for Chandler to a phase where we could like start experimenting and presenting an API and discuss what could be the API and discuss with other developers from Elastic. And then the phase 4 was the phase that after all the proof of concepts, we could really build a Markdown editor. And then the phase 5 is the phase that we call the adoptions, is when people inside Kibana start using the Markdown editor. So the first phase, I start like as a designer thinking how we could look like the toolbar, the text area, the preview. And I also want us to create a mock-up where we could test that idea of having like the embeddable components. So I start doing the designs in Figma. So it was like basically the initial concept. I was just testing if we're like writing and previewing what it could look like. And then drag and drop files. And this was the part that we really wanted to know if it was like a good idea. So to click something, and then a model will open. You could embed a visualization, and then you could have like a snippet. And at this point, as a designer, I would not worry if this was going to be the real snippet. I was just creating something so all of the team could have like start a discussion. And then if you hit preview, you could see the visualization. So in the phase 2, we start like showing these designs to all the company. Normally we send like newsletters from our team saying we're building this is like the idea we have, these are like the first designs. And then we created like a Google Doc, and inside the Google Doc there was like a feature specification where we were saying what we wanted to build. And then all of the different teams inside Kibana could go to the doc and say if they wanted to use a Markdown editor, what they want to use for. So different teams say, hey, we want to use for incident tracking and case management, other teams to add text to dashboards, other teams to annotation to visualizations, write email templates. So we start having a lot of use cases. So we decided, okay, let's create like a bi-weekly Zoom meeting, and everyone is welcome to see our progress creating the Markdown editor. And it was open for all the company. So after that, I continued my explorations. And at this point, I had already all that use cases. So I went back to Figma. And at this point, I started exploring the user flows. So basically here, I wanted just to make sure that that design that I was creating, if the design was going to work inside different parts of Kibana or inside other parts of other projects of Elastic. So like at this example, there is like a security that we call SIEM. This imagine there is like a conversation, like a case, and someone is replying to that case. So you can say, I had like a chart, a visualization, hit preview, and then the snippet. As if you can see at this point, the snippet is a little bit different from the first snippet because we start having discussion and I start having like an idea what the final snippet could look like, and then the preview. So we start testing the idea this way in different parts of Kibana, like if you want to comment inside the dashboard, or if you just want to copy a snippet and then pass the snippet and comment, and then you will have like the preview. So at this point, I start exploring these flows. And after that I knew, okay, this design is working, I open like a pull request, grabbing the Ian's pull request, and then I start changing the design and changing the styles and everything to match our design system, to make it like, because we have some standards, so I wanted to make sure that it was meeting the UI standards. So then this was like what it looked like at this phase. So let's see. This was like the pull request. As you can see, this is what Ian built, and then I start just adding button toggle, a toolbar component, a file picker, text area component, the border. But at this point, I'm like a prototype level. Everything is working. Like this is the Markdown editor. It seems that works, but I'm not worried about the API. So I put like a file picker that I thought it was the best file picker, but it was not really working properly at this point because then Chandler was going to improve that in a better engineer way. So in the phase 3 was the phase that the engineer started grabbing my Markdown editor branch. At this point you can see it's NewKB or Markdown editor. So Chandler started doing his own like research and doing his own code. And then during the meeting, he was showing to us how the snippet could look like. And this is like an example he was showing during a Zoom meeting and doing some tests. And then after this phase, we went to phase 4 that we called build out and implementation. And that this phase is the phase that we already did all the tests. So from my side, I knew that I had what I thought it was the final design, and Chandler knew, and he discussed during the meetings with other people and other developers from Kibana, and he knew that he already had like what he thought was the perfect API. So with this phase, what I did was I opened another pull request. This time it was like a feature Markdown editor. And we grabbed what we already had, and in this new feature branch, I started creating everything again, or rebuilding in a better way. But if you can see at this point, we start to do, we also had like a to-do list. different teams at Elastic work in different ways, but in my team, we use GitHub for everything. So everything is like public, and we create to-do lists here, and we discuss here. So this is what we decided to build. So we wanted to have a Markdown format, basically just rendering the Markdown, and then the Markdown editor that is with the toolbar, text area, and where you can have like a plugin. And the plugin is basically to give to developers the ability so they can use the Markdown editor to create their own plugins. So they just can decide what syntax they want, and then they have a logic to transform the syntax and to render the syntax. So they can create small things like adding charts or add any other plugin. But it was not perfect, and when we start building, I found out that I need to redesign a few things because I didn't handle properly the error states. So I had to go back to Figma, and I had to figure out how to improve the error state. Why is this not scrolling? Sorry. So my Figma is not working properly. Okay. So these are like the error states. So basically, we decided to have two different error states. One, if a file is not supported, and other, if you have like a snippet or a plugin that is not done properly, we will have like here the error, and if you click the error, you can see inside the tooltip what is the error. So after this phase of the error states, this is like the key to success, and it was like the documentation. So we built everything, and then the documentation, that was the part that Dave did it. And this is really important because having the documentation will make the adoption to be easier. So we created all the documentation for all the different parts of the Markdown editor. So let's see what the first release looked like. So the Markdown format, basically just rendering Markdown. So you just wrap the Markdown inside the Markdown format components, and it will render like this. And then we have like the Markdown editor that basically you have like the file picker. This is like a built-in plugin. If you hit preview, you can see. So you can add like, this is a plugin as well, a tooltip. You can see there's an error because the tooltip doesn't have the anchor and no text. So I can say hello. Oops. And then the Markdown editor and the Markdown plugin. And the Markdown plugin, it's really important, and it's like the beta version right now. And it's really important because to have all that user cases that we need for Kibana, we need to have this plugin because different teams are going to use the Markdown editor for different things. So the way the plugin works is basically you say what is like the icon you want, and then where is like the way you want to render a snippet, and then how to process that snippet. So then at the end, this is what a plugin looks like. There is like a chart. So you can decide this is like the UI. I can have like this palette, and I want 7 colors. If I hit preview, and it is just an example of a simple chart plugin, but then different teams can use for email or for other things. And then for the future, what we want to build, of course, new features, and of course, fix bugs. We already have bugs to fix. And these new features normally comes from after the adoption. So when we start seeing how different teams are using and what they need, it's when we decide what are going to be the next features. So lessons learned with this is to handle different scenarios really hard. For me as a designer, TypeScript is hard, really hard. And the documentation, it's all important to have good demos. If you see, we have that demo with the chart, and this is a good way to show what you can use the Markdown editor for. If you didn't have that demo, and if you're just saying you can create a plugin, probably no one was going to figure out what type of plugins. So always try to give a good example in good demos in your documentation. And also, during all the process, talk about your decisions with your colleagues. And that's it. Thank you. So you can make questions and also share your experience.
Thank you very much, Elizabeth. I'm going to go over and share my screen because we have a video from one of our sponsors, and then I'll get back to you with the questions that we collected on Slido. So let's get this going.
So why OutSystems as a software engineer? Well, actually, let's start by why as a software engineer. I loved complex problems since I was a kid. And actually, I went to the computer science because of that, to solve things that look complex, and they actually are complex. That's why I embraced distributed systems, which at the time was probably the most complex area that I was studying at the university. After that, I started OutSystems, and I fell in love with how we can solve complex problems on a simple way. And actually, that's what we try to do to our customers, allow them to have simple ways to solve complex problems, because we have all the complexity on our side, in our R&D side. And along the way, and actually looking back, I found out that all things have a part of it that is complex and that we can learn with it. And that's part of my path. I learned on the university how to deal with compilers, and I use that in OutSystems. I learned how to deal with distributed systems, and I use that to handle thousands of requests per second. I actually moved along the way and learned how to troubleshoot things where users are using online services, like a SaaS system, or they're on a bunker and I cannot access the data. So all these things have different degrees of complexity. And actually, I've evolved as a software engineer by moving to a different area, like learning how hard it is to fit with the demand of the end users, the complexity on the client side and the complexity of the user interface, which at the time I was like, oh, I'll never use this on the university. But then I found out that I used it, and that made me a better software engineer. That made me a more complete software engineer. So that's what we're going to talk on the next couple of videos. So stay tuned.
All right. Thank you to OutSystems for their sponsoring us. And now we're going to be going to our Q&A with Elizabeth. I had muted you, so you'll have to unmute. I think I can ask you to do that. And the first question that I have for you, as a designer, how do you and the development team manage each other's expectations in terms of what's feasible and what you'd like to see actually designed and built?
Sorry, can you repeat again?
So how do you and the development team, or you as a designer, how do you manage each other's expectations and like the understanding what is possible and what is desired?
So I realize basically as a designer, I feel that I'm mostly helping developers because mostly of the ideas come from the developers and challenges from developers. So like this example of the Markdown editor, it started as a developer asking, then another developer built something, and then we thought it could be part of the Elastic UI. but that's it. So basically, I think that I like to help developers in that sense, and I mostly feel that we follow more, at least at Elastic, the culture is more like a developer culture, and mostly all the designers have a developer background. So most of them, I think
Know each other.
yes, know each other, and we really value what a developer wants to do, and we always know what is possible and not, and to build.
Right. Thank you. So the next question is asking what's the feasibility of integrating the Markdown editor with other applications, for example, file storage services such as Dropbox. So like if basically connecting to other tools that you might use, how easy and how feasible is it in terms of what you've been building?
Yeah, so we always try to build, at least our components are always very dumb, is more like the structure. That's why we always try to provide an API to extend. So I think it's possible if you want to integrate with other things like Dropbox or a storage service, or like importing files, because with that plugin system, you can define what you want to, let's say that you wanted to have a file from Dropbox, and probably I'm not sure if the Dropbox has an API or not, but you could like drag and drop something that could create like a snippet, and from that snippet you could maybe define or where is like the ID or something that you need from the Dropbox API, and then connect to that API and then get back. I'm not sure if it's possible or not, but I think from a plugin level and having that API, you can provide your logic, and so I believe it would be possible.
All right, thank you. The next question starts by saying that it was a very interesting talk. I might have forgotten, but I also thought the same. And the question is about how the weekly open company meeting affected the development of the editor.
Oh, normally it's people have a lot of expectation, and sometimes it's really difficult to balance what we can create in our first release. So you can have people coming with a lot of ideas. Oh, we're working in a mail template, and we could provide all these email tags. And then we have to say, we can't have like a Markdown editor that does everything. So what we can provide is just a plugin, and your team has to implement the tags. And you can have like teams coming and say, oh, can we have this from scratch? We have this idea and the Markdown, but we have to think that we have like a broad audience, so we can't like just do something for one team. So but I think then sometimes it's difficult then to have like the adoption, because then the team they have the Markdown editor, but then they need to create the plugins, and sometimes they a little disappointed because it's going to take more time if they want to use it. But for us, we can't cover all scenarios. Then maybe the Markdown editor will take 1 year just to have email tags, to provide like charts and visualizations from Kibana, to have tags for cases management, or to provide logs. So it will be really a lot of work.
All right, so one final question, because we're running out of time. And given that there are quite a few Markdown editors out there, right? So a lot of tools have them. Did you avoid looking at existing Markdown editors? Do you look at all or as many as possible? How do you find the balance there? What's your strategy?
I think for me it was the most difficult thing because working every day with GitHub, I really know how the GitHub Markdown editor works. And then it's really difficult if you already think something and you don't want to make something similar. So my first idea was, oh, I want to create something new, different of every Markdown editor. But then when you start putting the pieces together, you start realizing why all the Markdown editors are very similar. There's no too many things that you can make to make different. You can have like a toolbar. For me, I just try to not follow the GitHub pattern. I try to think, we need a lot of icons, and especially if you're going to have plugins, you can extend. So we really need space. So for me, when you hit the preview, it's very small. And for instance, the one from the GitHub, you have the preview, and then you have another button to edit. So it takes a lot of space. So for me, I knew that we needed just a toggle button for preview, then to handle the errors. I don't think other Markdown editors handle the errors like that, having like that clicking and open like a popover. But I needed space to provide the error, and that was the way I found, and that's it. I looked at the other companies and other projects Markdown's editor, but I really tried to create my own version, different from the others. But I think at the end, it's a little bit similar because it's a Markdown.
It's hard not to.
Yeah.
All right. Thank you very much. It has been a pleasure. Thank you for your presentation. I hope you can continue following CommitPorto, and big round of applause, virtual round of applause, and talk to you next time. Take care, Zoet.
Thank you. Bye.
Bye. Right. Hope you all enjoyed it. We're ready for our next. Actually, I forgot. Before the next speaker, we actually have our second giveaway of today. So, Angel, I'm going to ask you to wait just one more minute. Thank you for joining us already. And thanks everyone that submitted questions and asked questions and is helping us make this conference better. And now I need just to find out. I just need to find out who won. Sorry, too many windows. Sorry about that. And the winner of our second giveaway is José Pedro. So the organization is gonna track you down by your email. Hold on. Congratulations. Thank you for contributing to you and to everyone that's been contributing. And we're now ready to go into our second speaker of this afternoon, Angel Rivera from Circle CI, and I'll pass you the stage. Just let me figure out how do I remove the share.
Yeah, no worries, man. Take your time.
This has been a. I should take a course.
One man show. It's difficult. It's not easy.
Well, there's a lot of people in the background, but
but you're the navigator. You're the captain, right? You're the pilot. So awesome.
All right. So you should be able to share your screen now and take control. And to you. Okay. Thank you for being here. And
no worries, no worries. Let me see if I can share my screen though. All right, here we go. Can everybody? Yeah. All right. Looks like it's cool. Cool. So thank you. Is it Simao? Simao?
Yeah, Simao. That's good. That's good.
Yo hablo español, pero I don't speak portugués.
Pero, sí, es lo mismo. Pero que vaya
casi. Yeah.
Casi.
Gracias. Okay, so yeah, thank you for having me. I'm really excited to give this talk. I know I wanted to be there in person this year, but obviously with COVID, we are not able to do that. But this is second best thing. Maybe next year, yeah, I can visit. But yeah, so today I want to talk about CI/CD and specifically more about agility, how to do things in a more optimized manner, and then also some of the issues with CI/CD and specifically pipeline sprawl. But if you don't understand what pipeline sprawl is, that's okay. It's something I made up, but it describes the situation I'm going to talk about pretty accurately. So let me get this going here. Okay, so before we get started, just a quick introduction. My name is Angel Rivera. I'm a developer advocate for Circle CI. I currently live near Philadelphia in the United States on the East Coast. And I work for Circle CI. And in my job, I basically go out and talk to developers. And what we're talking about generally is how people are using technology, how, I learned the patterns about that usage of technology, and I bring that back to my team here at Circle CI, so that we can basically add features to the tooling and the product that will help developers get things done faster, more efficiently, and consistently. So this talk is basically based on some of those conversations that I've had and some of the thoughts I've had about managing pipelines at scale. In most cases, right, teams, organizations, we start off building out code or projects in a very kind of on a small scale, right? So one repository, and then we start adding some automation to fulfill our CI/CD practices and principles. But obviously, if it's a popular product or project and starts getting used with high volume, those projects usually tend to explode, right? And in volume and in services, and in today's microservices architectures, we're adding more repos, we're adding more configuration, right? So that means the CI/CD tooling and automation needs to actually grow as well with that. And believe it or not, a lot of people don't really pay attention to that as much as they should. And then it begins to be a problem down the road. So that's what I mean by managing pipelines at scale, right? Is you're just having a bunch of success and with your code, and then it becomes a problem because you're not really able to manage the automations and the other things that occur, including, right, that the actual popularity and traffic that maybe you get from that. So with CI/CD tooling, right, we make our CI/CD practices, DevOps practices, all a reality using tooling. And when we're doing that, though, we're also encountering a lot of obstacles, right? So like I said, once you start growing that project and it becomes popular, you now need to have automation and processes in place that will help you deploy really good code and ensuring that there's minimal bugs in your code if any. There's a lot of other things going on behind the scenes, like security scanning, and we heard from Codacy earlier, right? They do static analysis. There's a lot of other things happening to make sure that you're deploying the best code possible to your customers. So that's where CI/CD tooling comes into play to help with those processes. But again, there's obstacles. So as developers, right, we're faced with we get a lot of pressure, I should say, so that we're releasing as quickly as possible. It's funny. I've been in this industry a long time, and now I see like a huge focus on speed, and sometimes at the risk of quality, right? So we're being pressured quite a bit now because we have all this awesome new technology. We're also doing things faster, but there are issues with that, right? And if you look at the word agility, it's basically the ability to move quickly and easily, right? I like to kind of take a step back when I write these talks and really focus in on some of the words that I'm using. And again, right, so if you look at the word agility, right, it's just basically the ability to move quickly and easily. But you know, we're in technology. We're building programs, application services. I wanted to kind of smash what it is that we do specifically with CI/CD and agility, and I kind of came up with my own definition. It's the same definition as agility, no surprise, but I added the word continuously, right? So when I'm talking about CI/CD agility, I'm talking about how we are continuously moving quickly and easily through all our projects, through all our processes, through all our automation, right? And then we also form that kind of iteration loops that we're following up again with those processes. So it's almost like a wash, rinse, and repeat cycle. So the two things I want to talk about in this discussion is basically pipeline optimization and then the pipeline sprawl. So with pipeline optimizations, right, these are just some of the things I'm going to touch on here: resource classes, concurrent jobs, caching, and selective processing. With resource classes, this is basically what I'm describing here is, you know, all of our code in our CI/CD tooling has to run in some runtime, right? And it could be a virtual machine on the platform. It could be a Docker container, whatever it is. It needs resources, and those resources help with, you know, processing that. And one of the biggest problems I find that people really kind of neglect is adequately sizing those compute nodes. So, you know, in the beginning, people start running their processes on you know, maybe let's say a 4-core CPU machine with, you know, I don't know, 16 gig of RAM. But eventually, as more teams are running, you know, your processes and your automation, those nodes actually become under resourced, right? Undersized, and they're not able to process that as quickly as it used to. And people forget, or they just neglect it. They don't really understand why their pipelines used to be, you know, a minute, and now they're 30 minutes, right? So one of the biggest issues is adequately sizing those runtimes so that you can complete those tasks quickly. You know, some arguments that I hear are, well, it's going to cost me more money, you know, to pay for that enlarged or that faster resource. But if you really look at it, what I've seen in the data is if you give it more horsepower, right, the resource, it'll execute things a lot faster and finish in most cases either at the same time or just a few, you know, minutes or seconds later. But it still shortens that time, right? And for that, you know, cost of that resource, which is actually like, you know, a few cents more, it's definitely worth, right, checking out and understanding how your runtimes are within your CI/CD tooling. So definitely, you know, look into if your resource classes are adequate enough for your builds. That will help with processing things faster and also give you the ability to process more things at the same time. And that leads me into concurrent jobs. So at Circle CI, you know, in the CI/CD tooling space, every job is just a grouping of commands that accomplishes a certain thing. And what I'm here to say is run your jobs as concurrently as possible, meaning run them in parallel. Do the things that really don't have a dependency at the same time, so that, you know, when you're having your pipelines build, they're building concurrently. And then try to avoid building dependencies unless you have them or need them, I should say. So if that means, you know, if you're packaging up your application into a Docker image, that's fine. If you're going to deploy that application to a let's say Kubernetes cluster, you can run those two things at the same time. Now, where it needs the dependencies, probably when you're going to deploy that application, right, to the Kubernetes cluster you just created in your automation. So, you know, again, always look at the dependencies in your jobs. Try to eliminate any kind of any kind of barriers that produces, because dependencies add time. They tack time onto your build, right? But they are necessary to kind of proceed to or promote to the next segment in your pipeline. It's just that what I see is a lot of people just, you know, building these dependencies that they think they need, but in reality they don't. And again, right, we're trying to create this CI/CD agility where we're moving quickly and continuously. So caching is another mechanism that you need to implement in order for your automation to actually really zing, right? To move quickly. But I will warn you to cache cautiously. A lot of folks cache a lot of unnecessary dependencies and libraries and things like that. Just cache what you need, right? And only update the dependencies that need updating. A lot of package management systems now allow for that, but still, I see a lot of weird caching mechanisms that are really efficient and cause a lot of problems with their processes. And selective job processing. What I mean here is, do you really need to run certain tests? Like there's tests that we know they're always run, and they never fail. So there's an issue there, right? Like, is your test really useful if you're always getting a happy path green build on those tests? Keep an eye on that. Make sure that you're doing as much observation on your test, making sure that you're getting the results that are valuable to you instead of just running things just to run them. Another parallel selective builds is conditional job execution. So what I mean by this is make sure that you're looking at how those jobs are actually run as far as the condition logic, right? So if you have, let's say, for instance, a couple of deployments to Kubernetes, make sure that, do you really need to have that in place as far as like promoting to like staging, production, or whatever? People tend to kind of just zip right through, and they're wasting a lot of build time waiting for like things to deploy to target environments that they really don't need at that stage in their pipeline, if that makes sense. So yeah, just keep an eye on how you segue into different jobs within your pipeline, because that also can save you time and money and resources, right? So the final thing I'll leave you with optimization is set target build durations. What I mean by this is a lot of folks just let their builds run for 20 minutes and they accept it, right? What we're trying to do here is increase efficiency and optimization. And I like to set targets now to like 1 minute. So all of my builds, I want them to complete in 1 minute. And I know some folks are probably like, whoa, that's like not going to happen with certain stacks and maybe deploying to cloud providers. But and that's okay, right? So if I'm deploying to like GCP and my Kubernetes cluster takes 6 minutes, that's okay. I know that because there's a constraint from the cloud provider, right? So it's not one of my problems, so to speak. It's more that the actual technology on the provider, right? The target environment is there's a condition there that I can't change. But I still have that standard of 1 minute. And if I can, keep going back to it at different intervals, right, and looking at it, and if I can, shave off a few seconds here and there, depending on how I'm deploying, I will do that to get closer to my 1 minute target. But as long as you keep that goal, right, and you work towards, achieving it, I think that's a really nice kind of way to keep going back to your pipelines and looking at, optimization, making sure things are running smoothly as well as, efficiently. So let's do a quick recap, right? On the resource classes, just make sure you have adequately sized compute nodes. Don't worry about the costs, right? If you're executing faster, that means you're executing things quicker, and this might cost you a little bit more on the front end, but save you a lot of money on the back end with time. Definitely look at running jobs concurrently. Avoid the job dependencies because those things are blockers and they will slow you down. And caching is a big one. Just update the changes that need to be updated. Don't try to update the whole thing. And yeah, don't cache everything or all the things as some people do. Selective job processing, really important here. I think that, we need to kind of take a step back and look at our pipelines and only, execute the jobs that need to be executed and when they need to be executed versus just, do it all at once. So let's talk about pipeline sprawl. So with pipeline sprawl, this concept is a little bit more into like how we actually manage the workflows and the jobs within a CI/CD tool. So most CI/CD tooling, modern CI/CD tooling, basically has the pipelines defined in a config file. Now, I know there's others that have a GUI, right, where you're pointing and clicking and creating these pipelines. But in general, most of them have this capability of just defining your pipelines and your workflows in configuration files. Now, normally, and in today's kind of more modern architecture of software development and deployments, we're doing it. We're leveraging micro service architectures, right? And again, right, this is, excuse me, in general, what's happening. So the math here is usually a 1-to-1 ratio where you have one code repository and then one pipeline configuration file where you're defining all of your workflows for that specific repository. So most of that, right, is defined in a YAML file. And, you know, whether you like YAML, whether you hate YAML, that's okay. I'm not here to play politics in that arena. But I can tell you that YAML is not a programming language, right? YAML is a data structure. It's just like JSON, right? Except for obviously the cosmetic syntactic differences. But it's a data structure. It doesn't have the capabilities for you to perform logic in it, like natively, right? So what happens with CI/CD pipelines, there's a lot of redundant code, right? A lot of redundant syntax. And the reason that is because you cannot have variable, right, parameterization or anything like that within YAML. So again, right, as that code becomes redundant, your syntax will grow in complexity. So now I'm specifically talking about that code file for your pipeline. And what happens there is that becomes very hard to navigate, right? So now you have, let's say it grows into thousands of lines of syntax. Now you're, you know, and it's all repeated syntax. It's a pain in the butt because now you have to kind of, you know, figure out where your changes are going to happen. And, you know, it's a very laborious process. I've been there. It's not good. Also, right, you start moving into now. So if you have all those changes in that big pipeline configuration file, imagine if it goes, you know, across the board into your repository. So not only do you have, you know, this, let's say thousands of lines of configuration in your file, now multiply that, right, into a bunch of other repos. Let's say you have even 20 repos. That's a lot to maintain. And when you have that difficulty maintain, you're now in a dilemma. Like, how do I solve this? Right now, you're becoming inefficient in managing your pipelines, and it's all due to the sprawl, right? It's just volume as usual. So we thought about this a little bit, and you know, with GitOps, people were saying, well, maybe you can implement some GitOps solutions, you know, to kind of help with that. But it's not really an option, and the reason is just the nature of what GitOps. How GitOps is kind of defined doesn't really, I don't see any strategies. I've been trying to kind of shoehorn it in, but it doesn't really fit for this specific problem. So one of the things that people do is they hard code commands into their YAML, and that, you know, again, creates that huge sprawl in the syntax. This is kind of an example where, you know, people right out of a Circle CI file that I use for a pipeline. And I just want to show you kind of what hard coding means, the little bolded colored letters there, right? It's an AWS S3 copy command. But again, I'm hard coding that. And imagine if you did that, let's say, you know, 10 times in one file. Now you multiply that by, let's say some of our customers have 1,000 repos. Now you have 1,000 config files. So if you have to make one change, that's a problem. You can even, you know, I've tried to automate this stuff. The only issue is, though, now you have to build, so I can build scripts to, you know, replace text in all these files at one time. The problem is I have to build automation to then validate my automation and make sure that that's working. And so, you know, you go down a huge rabbit hole of what's like the bottom line, like how am I going to verify 100% that everything's good to go? So yeah, there's a huge problem there. And but there is options, right? And one of the things I looked at when I was kind of formulating this talk and trying to give solutions to this, and it kind of dawned on me that this is, you know, no different than any kind of coding problem that we encounter as developers. So I started looking at concepts like object-oriented programming, right? We already know these things. We already kind of handle these problems when we're writing code. So one of the things is that came to mind is separation of concerns, right? So obviously you have to define or identify common pipeline patterns. So if you have that AWS upload pattern happening, 10 times in a file, that's a concern that you can separate, right? And once you have that identified, you can create abstractions, right? And then once we have those abstractions for that functionality, we can then encapsulate it and then treat it just like any other class, right? In a programming language. And we can add, properties, right? And functions that specifically pertain to that pattern that we've identified. And of course, right, once you have that parameterization in place, you can recreate, right, reusable modules, and then that can help you with managing all of that functionality in one-stop shop. And this is where I kind of advocate for building pipeline type libraries, right? And some CI/CD tools already offer that capability, like I would say natively, but I think every CI/CD tool has this capability. People just have to implement that workflow, right? So they need to just create these scripts, keep them in a centralized place, and then share them across their repositories. This is a good example of how you could leverage a script and add that reusability into your pipelines. So if you look at that final run command, what I'm doing there is I have a folder with scripts in it, and then there's an S3 upload script, right? And then I can just put variables against that or submit arguments as variables into that script file. And it gives me that ability to just, reuse the same code without having to, cut and paste and put that all into the hard coding that into your YAML. That gives you a lot of flexibility and also gives you that kind of one-stop shop, right, to manage that code. You can manage that functionality just by changing that one script file, and it will help across the board to any of your repos that are using that. So again, right, it's about managing that volume as well as being consistent and efficient with all that. It also adds portability, right? So this helps with minimizing vendor lock-in, which I know all of us kind of are held hostage by a lot of these companies that, we've been using a tool for 5 years and we want to jump into maybe switch to a new tool that's more beneficial for our workflows and our processes, but we can't. Why? Because we have 100 repos that we need to then outfit for, these new tooling. But if you kind of use this separation of concerns and encapsulation, you're able to then keep that stuff as, minimally away from that lock-in as possible. And then it helps with adding, or at least managing that lock-in a little easier. And when you want to start, porting things over into a new tool, which is going to happen, right? Like, it's technology. If you're not changing your tools, that's, I would say, every 3, 4 years, 5 years, you're going to have a huge problem later on. It's going to cost you a lot more money versus, keeping, I would say, practices in place that help you observe what's happening, making sure that, things are as separated as possible, encapsulated as possible, so that you can just pick up your stuff and move on to the next tool if you need to. I always keep an eye on that. I've been burned so many times by just, doing things the way the vendor wants you to do it, and then being locked in forever and it costs you so much money. But yeah, just keep an eye on that as well, right? Think of it as kind of future-proofing your operation. So at Circle CI, we actually, solved this problem for our customers because we saw this, right? We run so many builds there. And what we did was we created this concept of orbs. And what orbs is basically on the back end in the platform, we enable our developers to define their pipelines using parameters. So what we've done is we built like a DSL, domain-specific language within Circle CI. So now our users can create parameterization, right? They can actually go ahead and build these reusable bits of code, and then we can also package them up into what we call the orb registry, and that lives, and we maintain that, lives online. It's almost like NPM or Docker Hub, but for Circle CI functionality and configuration pipelines. So real quick recap, identify, right, when you're with pipeline sprawl, identify your common patterns, encapsulate that functionality into parameterized scripts, and use those scripts to consolidate and centrally manage, maintain your code. And then that will help with vendor lock-in, also adds a lot of portability. And that's the end of the talk. I'm sorry I was rushing through it. I wanted to get through all the material, but I'll have any conversations or questions. If you want to reach out to me, I'm at Punk Data on Twitter. I'm open to any conversation. So thank you.
Thank you, Angel. Before we move into Q&A, I'll just play another promotional video from one of our sponsors, and I'll get back to you. Jesus, I'm really not very good with this keynote thing. I don't know what happened. Seems we can press the mouse anywhere. Sorry, guys. Sorry, Bosch. All right, now for the Q&A. And again, I apologize to Bosch for breaking the flow of their video, but there's too many buttons. Angel, also before that, just we're a little behind schedule, but I don't think it's too serious. So we'll have a couple of questions for you. And then Rob is already on the line and ready to come in afterwards. And but let's go with the questions. So the first question is, in a large project with more than 20 elements with different areas of knowledge, can we maintain the definition of agility? What strategies to use if it's not possible to have a smaller team? What do you?
Yeah, so I think, so that's a good question. So if I think that number one, if you're implementing, if you're working on a large project like that with a huge team, and there's a lot of moving pieces, and it's kind of a restrictive, I guess, either management or culture, I would definitely suggest that, you take a couple of your more passionate team members and actually start to kind of formulate some real CI/CD practices and principles. What happens in large teams, the size of the team doesn't matter. What matters is how the teams are working, right? And what I was speaking to is specifically tools, but if you go an abstraction up, you should really look at continuous integration practices and principles, right? So that will help you kind of break those those 20 elements. This sounds like it's already kind of compartmentalized. So take those compartmentalized pieces and figure out who's kind of the biggest contributor to that, or kind of the one, because right, every element has some leader or someone who's really passionate about it, and start talking to them about how they're developing code, how their team or portion of that element is delivering code to the actual project. And then, have those conversations about changing the culture of how that software is being built. I know those are difficult to do, and it's almost like really hard to kind of focus in on one thing. But what I would do is focus in on the easiest element of those 20 to actually make easy changes that are not really, impacting a lot of things. And the reason I say that is you want to get those small wins in, right, when you're changing culture. And then once you change that one thing, tackle another one that's not so impactful, and then do it again. So it's almost that iterative kind of process. The problem is, again, it's primarily culture. It's just the way people work, and it's really hard to change people's work patterns. But I think the idea is not to actually change it, but to incorporate it into the way your team does business, if that makes sense.
Yeah, that's good. Thanks. So one last question. How would you go about reusing common CI/CD usage patterns across teams? Do you think that is the challenging issue, or is it doable?
Oh no, it's totally doable. Again, I think so. The main thing in convincing people that, especially with CI/CD, I have to tell you, I work for a CI/CD company. People don't really care. There's only like maybe 2 or 3 people that actually, give a shit about it, to be fair, in an organization, on a team. And those are usually the people that are managing the pipelines, right? So again, going back to kind of that culture shift in your teams, you definitely need to look at, if you're really passionate about the CI/CD, you're probably the one managing it. So what you want to try to do is bring as many people on board to kind of understand, number one, what the automation is doing for them, right, and how it benefits them. Because at the end of the day, what we're doing is, when we're implementing CI/CD and all this agility talk, right, it's all about feedback loops, right? So as a developer, isn't it awesome if you can just write some code, commit it, push it up, and then like I said, in a minute or two, know if your code is broken, right? That would be so helpful, because then you can fix it, right? And make, just keep working on that problem until it's fixed. And then you can move on to the next task on your sprint list, right? Like that's awesome. But the problem is developers are focused pretty much on what they're doing. And then, they're just sending these commits off into the void. And then if it fails, then they do something about it, which is the workflow that should happen. But they don't really, care about what's going on and invest inside that pipeline. But with tools like Circle CI and all the other modern tools that are out there, and if you implement continuous integration properly, you're able to go in and see exactly what that pipeline is doing. And then you can also, like, let's say I create a new feature, right? And I want to add maybe an integration test for that new feature. As a developer with these tools, you can do that. You just have to understand where that pipeline is, because you can branch off in isolation, and all those builds will run by itself without impacting, the master branch or anybody else's work. So yeah, if you're a developer, just, spend some time understanding what those processes are. And I promise you, the people that are managing that will be happy to show you what it is that it's doing and how you can contribute.
Perfect. Thank you very much, Angel. I think you've been listening to the conference, which is great. So if other people have questions that they want to ask you on YouTube after the call, and we'll make sure to share the questions with you afterwards. So the ones that were on Slido. But thank you very much for being here and for your presentation. And I'm say goodbye now. And all
right, thanks, and stay safe, everybody. We'll see you soon. Take care.
Take care. Thank you.
Bye-bye.
Bye. All right, this time is flying when you're having fun and learning cool stuff. And now we have our last speaker of the day. Good morning, Rob. Can you hear me okay?
Good morning. I can.
Welcome. Welcome to CommitPorto'. Sorry, we're a little behind, but I hope it's okay. And
no worries.
Very happy to have you here. And I'll know without any further ado, feel free to share your screen and kickstart your presentation.
Perfect. Are you able to see my screen?
Yep. Bright and clear.
That was such a fun conversation about DevOps and continuous integration. That's a passion of mine as well. And so I'm really excited to see that go. I'm going to talk about something completely different. We're going to talk about databases in the microservices world. Here's the part where I tell you I'm definitely going to post my slides tonight. You'll go check my site tomorrow, next week, next month. In about 3 months, you'll get tired of waiting and you'll email me. In about 6 months, I'll reply and say, no, I'm definitely going to post them tonight. And I'll never post them at all. I've been that guy chasing the speaker and I didn't like it at all, which is why you can go to robrich.org right now. And here's, click on presentations, and here's databases in the microservices world. And the slides that we're going to look at right now, they are online right now. While you're there, you can click on About Me and see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp in your area, hit me up on email or on Twitter, and let's get philanthropy installed in your neighborhood as well. Some of the other things that I've done, SQL Source Control Basics, minus Chapter 8, that was fun. I worked on Gulp as a core contributor in version 2 and version 3. And one of my claims to fame, I replied to a .NET Rocks podcast episode. They read my comment on the air. They sent me a mug. Woo! Okay, so let's talk about databases. Databases in the microservices world. We talked about this guy. So typically when we're looking at architecture, application architecture, we will refactor from monoliths to microservices. I really like this journey and I like this analogy of how they explain it. We started out with a big ball of mud, spaghetti code. We moved into ravioli code where we had layers. And then we moved from there into, we moved from spaghetti to lasagna, and from lasagna to ravioli, ravioli being, lots of little microservices. With each step, each piece got more contained, simpler, and that was really cool. We moved from this monolith here on the left to microservices on the right. So on the left, in a monolith, deployment was hard and we didn't want to do it very often. So we saved up all of our changes. We deployed one big package, probably on a call that started Friday night after work and ended hopefully by Sunday afternoon. and we moved towards microservices here on the right, where deployment was no longer hard. Maybe we're using containers, or maybe we just got better at it. And so now each of these little pieces is able to be replaced at a moment's notice. And that's really, really cool. We got from monolith to microservices. Each one of these microservices now can be scaled independently, and we can get a whole lot richer experiences with a whole lot simpler code. One of the things of microservices is that each one owns its own data source. And so that's really cool. A microservice now doesn't need to worry about, well, is this field obsolete? Am I the one that can maintain this? What if I change its data type or its length? Who do I need to coordinate with? Well, that microservice owns that data source, so we don't need to tell anybody. I own it. I can evolve my data source together with my microservice. So that's really cool. Microservices, it does one small job. They're easy to deploy. They can scale independently of other content. They're easy to replace. And the big one, it owns its own data, which is wonderful. Because it owns its own data, it can evolve its own data schema. It can evolve all of the content within that data store. That data is the responsibility of that microservice. Yet usually when we go towards these microservices, we end up here. where we have lots of microservices and one monolithic database. We've broken that rule of a microservice owns its own data. Oops. Well, why do we end up here? We probably end up here because we went and asked the DBA once, hey, can you do this? And they said no. Well, the DBA is trying to protect the safety of the data. And the way to protect the safety is to make it change less. Well, kind of. That's probably not the real reason. Probably the real reason is that provisioning databases is a lot harder than provisioning applications. In particular, if we have databases, we need to get them to have normal backup mechanisms. We need to get them to authenticate in normal ways. It's really easy to accidentally forget that. And we log in with SA and the password is password. And now our database is exposed. That's not okay when we're in a microservices world to have our databases exposed just because we forgot. Or even worse, backup. Hey, can we restore a backup copy of that database that we have over here? We never backed it up? Oh, well, now we're really sunk. So it's not that the DBA is trying to be mean, but provisioning databases is hard. We need some automation around this to be able to provision the databases and to enroll them in authentication mechanisms and in backup mechanisms. So if we have to have that monolithic database, there's mechanisms that we can do in our code to make it feel more like lots of little databases where each microservice can own its own database. Well, it doesn't own its own database, but we have this bounded context, this little small circle around the portion of that data that it needs. Let's consider an order entry scenario. In an order entry scenario, we could do, we probably need the product database, the product table. We'll need details about the images and the product description. And so that bounded context will encompass that product table. But in a fulfillment center, we don't need that. We don't need the images. We don't need the fancy description. Probably all we need is the product serial number, maybe the barcode. And so the bounded context for the shopping cart is that product system. The bounded context for the fulfillment is around the orders and around availability, pieces in the warehouse, how many do we have left, what's the shipping address? Those types of things will end up in the bounded context with the fulfillment process. So a bounded context is a great way to get to what I'll term micro databases. We have microservices that handle the services in our application, and we can have micro databases in our system that handle the data for each microservice. These micro databases can be exactly as we suspect. If we have enough automation, in particular, to be able to spin up a database, to enroll it in the authentication mechanisms, and to enroll it in the backup mechanisms, then we can get to micro databases. What's really cool here then with micro databases is they are owned by one microservice, so they can evolve according to the needs of that microservice. And for other microservices, they can call this microservice to get at the data in that micro database. So only one microservice will read from each database, and that's perfect. But then how do we do kind of more complex mechanisms? How do we do joins? Well, a join is a mechanism of kind of grabbing some of my data and some of your data. Well, instead of reaching off into your data store, that service could expose a feed of transactions. Perhaps we're using an enterprise service bus like Kafka. When that order fulfillment, or when the shopping cart service gets a new order, it can publish that order to Kafka. When other services need that order information, they can listen to that service, and if it's an event that they care about, they can save it off into their own database. Now when it comes time to do joins, Now we're not joining against the other guy's database. Rather, we are joining against the data that we got off of our own event stream. We save that off into our own micro database, and now we can do the joins on all of the data that we care about. Now we don't need all of the details of the order, but knowing that that order happened and who it happened for, maybe the total amount charged, that's the things that we'll store in our micro database so that we don't need to join against somebody else's micro database. Another interesting thing in micro databases, so who owns the customer record? That's one of the places where we'll kind of default back to a monolithic database because we want this foreign key off to customer and we want all of the details in the customer. So for example, in the shopping cart experience, we'll need a customer so that we can place an order against that. So shopping cart definitely needs to add some rows to the customer. Billing will want additional rows in the customer record, like the credit card details. Human resources is great for having lots of secrets, and so they're going to want to stick all of those secrets in the customer record. Sales is probably the first person to see the customer record, so maybe they should own the customer record. They're the ones that find the prospects and leads. They're the ones that convert them into customers. Well, kind of. There's a very different mechanism in a prospect or a lead compared to a customer that we sell something to. If we have a customer and we create a sale to that customer, then we need a shipping information. We need a full address. By comparison, a lead, I may only have the name and the phone number that they wrote down. I may not even have an address at all. So if sales owns the customer record, by the time we get to the shopping cart, then the customer record may not be complete enough. So who owns the customer record? Instead, let's create a new microservice. And let's call this microservice the customer microservice. It owns the micro database that keeps track of customers. And in that customer database are two fields, the customer's primary key and the account number. That customer service is responsible for keeping this micro database and keeping that account number unique. That's it. So now shopping cart can have a foreign key off to this other microservice. Billing can keep the credit card information in its own customer profile that has a foreign key off to this customer microservice. Human resources can keep all of their secrets safe and they don't bleed out into other microservices. They'll keep them in their own customer profile, which is different from billing's customer profile. And then sales, they just need to call the customer microservice and say, hey, can I have a new account number? They get back that account number and they can do whatever they need to with that foreign key off to the customer table. This is perfect. We've created a new customer microservice that is able to create that mechanism so that all of the other microservices can store their data and not need to worry about who owns the customer record. The customer record is now really narrow. All the other details associated with the customer can live in the bounded context in the micro database where that detail makes sense. So micro databases, we got here. We have enough automation to be able to get our databases spun up. We have authentication and backup mechanisms that happen automatically. And we can use bounded context inside of our microservices to ensure that that data in our micro database doesn't need to bleed into other microservices. So now what's really cool is that all of these micro databases don't need to be the same type of database. They can be whatever type of database they need to be. That's perfect. This quote is by me. Right now. So let's look at some of the database types that we can choose from. Because each micro database is its own database, then they don't need to be the same vendor. They don't need to be the same type. We could look at a SQL database, a relational database, a NoSQL database, document database, and a lot of different database types. Some of these may be new to you. Some of them may be old hat. Let's look at each of these types. And as we look at each type, let's look at the characteristics, pros and cons, best use cases, some examples of when we might want to choose that database over another database? First up, SQL databases. We can think of this like a spreadsheet. Every column in that spreadsheet has exactly one type of data, and every row in that spreadsheet is a complete row of all of the things. As we get going, we may want to split this row into, split this spreadsheet into many spreadsheets. So we might have an order spreadsheet, an order table, and a line items table. We'll use SQL, and SQL is this really elegantly tuned engine that allows us to dig into all the particulars of that query in a more or less standard mechanism. One of the primary things about SQL databases is that they are atomic. I know that when the data goes in, either all of it is in or it all fails. It all succeeds or it all fails, and there is no kind of halfway mechanism. By comparison, we have eventual consistency. Eventual consistency, eventually they'll all finish. We can think of this kind of like a credit card statement. In my credit card statement, I know that all of these transactions are done. But if I walk up to Starbucks and I swipe my card and then go check my credit card statement, it may or may not be there yet. Eventual consistency inside SQL Server says that once I finish doing that credit card swipe, I know that that's on my statement. So SQL databases, that ACID compliance is really one of its primary mechanisms. So on the upside, I have this strong schema. I can do table joins. It's a very optimized and standard engine and is familiar and compatible syntax. Now, I grant there are differences in different vendors, but they're slight in comparison to other mechanisms. On the downside, a SQL database was built in the era when we had single-threaded mechanisms. So to scale up a SQL database probably means to buy a bigger machine. Now, we may reach the point where there isn't a bigger machine. And so scaling in SQL databases is usually vertical. There isn't a great mechanism for horizontal scaling. So here's some examples of relational databases, and you might choose a relational database for everything. If you're stuck in that monolithic database mechanism, it's probably a SQL database. By comparison, we can look at NoSQL databases. And well, everything that isn't SQL is technically NoSQL. So let's call this one document databases. Document databases will store data as JSON. The cool thing is I can nest fields here. I can put objects under other objects, and I can store all of the data probably more similarly to the way I use it in my application. On the downside, I don't really have a mechanism of joins in a SQL data, in a document database. On the upside, all of the documents can be different within each of the collections. So rather than a table, I'll have a collection, but there's no real way to join on the collections. Document databases focus on eventual consistency and usually are optimized for reads and scale horizontally. So on the upside, there's no schema that I need to fight. I don't need to adjust the schema to tell my database how I'm using my data. On the downside, I probably have a schema inherent in my application. So I have to add additional error handling over the top of my application for cases where the data may not be in that form. Because I don't have a SQL mechanism, I probably have an SDK for each language that I need to handle. This SDK is different between each language. And so interacting with a document database is a little weird. That does make document databases a little bit more complex to handle, and it makes the query engine a little bit less performant. They haven't had those same decades of tuning like the SQL engine. So document databases, here's some examples of document databases. They're great when I need to grab all the things really quickly. So for example, a product catalog or a news site or a CMS, where I need to grab all of the pieces associated with this page or this article, including the article's title, the author, the author's picture, any tags or categories associated with that. All of that will be inside this document. I go read that document based on the URL, and I have the entire page rendered really, really quickly. So that was really cool. Next up, graph databases. Graph databases are interesting in that it's not just data, but it's also relationships. Graph databases have nodes and relationships between nodes, and I can put data both in the nodes and in the relationships. I end up with this really cool syntax of querying that allows me to navigate through those relationships. So we can think of a graph database as great for friends and friends of friends. So how is this different from a table that has 2 foreign keys, one off to each one? Well, it's about that query syntax, and that query syntax makes it really easy to do that. Without that, I have a whole lot of join to myself 3 times to try to get friends and friends of friends, which graph databases are really tuned for. So on the upside, a graph database is particularly tuned for this mechanism of relationships. On the downside, it's not tuned for other things. So there isn't really a mechanism of a join in a graph database. That's an expensive operation, where in a regular SQL database, that would be just baked in. So here's some examples of graph databases. Graph databases are great for messaging apps or social networks, recommendation engines, places where I need that relationship and I need to be able to navigate between this and the related things, or between friends and friends of friends. Next up, a key value database. A key value database is something where I have a key, I have an ID, and I go query by that ID and I get back some blob of data. And the format of that blob is somewhat irrelevant to the database. Oftentimes we'll store it either as a binary blob, maybe a serialized object, or as a JSON blob. But ultimately, the value in that value database is just whatever I want. In each row, I can store anything. It doesn't need to even be in the same format. I can read by ID and I can get back that value, or I can set it based on ID and I can add that value to my data store. We could think of this in a SQL metaphor as a table with 2 columns, a primary key and a big binary blob. So it's great for configuration. It's great for those places where I want to do that get by ID. Now I can do a get by ID, that works out really well, but I can't really get by anything else. The way I would do a query based on content within the value is I would basically read each value, each entry in the database, and then deserialize that value using whatever mechanism made sense and query against that value. It's really, really inefficient. So key value databases, here's some examples of them. Key value databases are great for caching or configuration, for user session data, places where I'm always going to read and write by ID. And then that value can be whatever it needs to be. So in one configuration line, that could be a big blob of JSON. In another configuration line, it could just be true or false. Whatever I use to add that data to the data store, I can use that same mechanism to deserialize the value and get it back out. Next up, time series databases. These are great for very fast ingest of real-time data and then querying that data based on a time window. What's cool here is that that time window, I can specify a bucket of minutes or days. And unlike a regular relational data store, that bucket will yield not just one value in the cell, but a range of values in the cell. Now that I have that range of values, I can look at that range and I can do interesting things like min and max and average and count. Those are things that I can't do in a normal relational table because I only have one value. It's also great for highlighting missing values, which can be really helpful. A time series database has those windowing functions that allows me to treat those events in buckets. On the downside, I've optimized for that, so it's not really great for other things. Here's some examples of time series databases. They're great for IoT, for real-time events. Maybe I'm harvesting events from mobile devices or industrial sensors, stock trades. When I have a lot of data that is very time sensitive, then I can use a time series database to harvest the events, look for anomalies or patterns, and start to do some really interesting things with the data there. Next up, text search databases. Now, when we think of search, we think of something like a Google search engine. That isn't quite a text search engine because in that case, I've paired it with a natural language processing engine. And the natural language processing engine will harvest the intent of the query and then query against a text search. When I have a text search database, it's great for finding content within a document or finding the documents that have these matching keywords. I use an inverted index to be able to do it. Text search databases are great for that text mechanism, so I can't store other data. And some text search databases will actually add the schema at query time, which is really interesting. On the downside, I don't have relationships in text search databases. It's only for finding the finding position of that text in the database, in the document, or finding documents that have this text in it. One of the downsides for this is stop words. A, an, the. These are words that don't have semantic meaning in English. So we might choose not to index these stop words. Well, if we're in another culture, in another language, those stop words will be different. And so now do we create a huge list of stop words that match every culture? Or do we ignore all the stop words so that we can work with all cultures, understanding that we're going to have a really big inverted index for A? Take the example of streets. Well, maybe ST and RD and street, road, and AV, we'll just leave those out of our index, together with the other stop words like A and the. Well, now we have a street called Avenue A. Well, Avenue A, so we strip off the AV part and we strip off the A part. Now, did we just index nothing? Stop words can be really domain specific and also culture specific. And so we need to be careful of those stop words inside of a text search database. The other downside, it is only for text. So if we want to do other types of things, we'll need to store those things in other data stores. Text search databases. Here's some examples of text search databases. They are great for finding keywords in documents and finding matching documents so that we can examine them more carefully. Object stores, blob stores, file systems. Here, we can treat these roughly like a file system. If we look at, say, Amazon S3, we have a key that kind of looks like a file system. It isn't a file system, but we can pretend and treat it that way. The value then is a big binary blob. And so object stores are great for storing those big documents. Great for large video files, backup files, log files, things where the value is very large and wouldn't fit in a normal table. An object store is probably a great place for this. On the downside, I can't really query by that. So let's imagine we have a backup as our value. I can't query the object store and say, when was the last time we backed up this file? To do that, I would have to read each binary blob, deserialize it, maybe ungzip it, and take a look at that content. That is painful. So we may mirror the metadata associated with an object store in a relational store so that we can do that metadata searching. Once we identify the rows that we care about, now we can deserialize those and go grab the actual file out of the object store. So here's some examples of object stores. We mentioned Amazon S3. These are great for big things that need storing, but not random access. If you do need random access, you need to pair this with another data store. Column stores. Column stores are really interesting. They're an adaptation of relational stores where data is stored in columns. Here on the left, we have a typical relational data store where we have all of our data stored in rows. On the right, we have our data stored in columns. So imagine I have a table that lists the country or the state or city within the country. I probably only have a dozen or a few dozen cases of that. So if I'm listing the country, I can compress this data really well in a column store. And so column stores are really great for storing data very compactly, and also because it's smaller, seeking and bulk reading that data. I'll use a row store when I need to be able to do random reads and writes, and I'll use a column store when I need to do bulk reads and writes. Like, for example, analytics. So column stores are great for analytical queries. They're great for bulk reads and writes. They're not great for transactional things. Here's some examples of some column stores. New SQL databases. Now this is really cool. We can think of a new SQL database as SQL with an SLA, SQL that is partitioned. So in a similar mechanism that I have for document databases where I do horizontal partitioning, I can do that here with new SQL databases. Here's a MemSQL example where I have aggregators, and each aggregator will accept the queries and split that across all of the leaf nodes that actually store the data in partitions. So I'll partition my data into lots of pieces. I'll take the query and I'll send it to each node that needs to participate in the query. It will harvest the rows that match and return that back to the aggregator so that we can get a combined deterministic result. Now, because I'm scaling horizontally, this actually performs a lot better than a traditional SQL database. I'm no longer limited to the one big box or the more and more expensive box. New SQL databases. They are much cheaper to scale, but they do have more moving parts. So for example, what happens when I do a join? Well, when I do a join, some of the data may be on this partition and some of the data may be on this leaf node. So I may need to move some data across the network to accomplish a join. Now, we'll probably put all the leaves on the same LAN in the same availability zone in the same region, or not in the same availability zone, but rather in the same region in the same LAN. So network latency is probably not a huge concern, but it is an additional moving part in this solution. Here's some examples of new SQL databases. They are great when you're outgrowing your database, when that spinning wheel loading the dashboard is taking too long. Because it has that horizontal scaling, then you can do a lot for making it run a lot faster. Add to this query tuning to make sure your queries run as well as possible. And now you can get some really great performance out of your SQL database. Now, new SQL databases still have the ACID compliance. So once I've committed it, I know I'm going to get it back out, but they are distributed. So it's kind of the best of a traditional SQL database together with a document store. Now, as we look at databases, probably we've seen features that we like in some of our favorite databases, and we can say, well, my database is this and that. A lot of databases are moving more towards a hybrid database, where they have features of lots of things. Perhaps they're a traditional relational database, a SQL database, but they also have a JSON data type so that they can reach into NoSQL workloads as well. Now, the benefit of a hybrid database is you can kind of blur that line. The downside is it's really easy to try to do everything and end up doing nothing very well. But hybrid databases tend to give you more options. Here's that spot. Grab your phone or grab these slides from robrich.org. Here's all of the database types that we looked at. A really quick description of that type and when it's best to use this type. We looked at architectures. We looked at the monolithic database that we tend to fall into. When we end up with this architecture, bounded contexts are a great way to start pretending that it's micro databases. And then as we get that automation to enroll our databases in backup and authentication, we can move to micro databases where mirroring our microservices, each micro database is owned by exactly one microservice. We may have an enterprise service bus that publishes events between databases, but that micro database is owned by that one service and can be of whatever type or style it needs to be. So we end up with these micro databases where we don't need to have the same kind of database for each microservice. Once we have the mechanism for enrolling them in authentication and backup, then we can get whatever vendor, whatever data store is correct for our problem. And we can start to mix and match them. Perhaps we have an object store or a text search database, but we also need to do some joins. So we'll match that with a relational database that stores the metadata. Or perhaps our relational database is not fast enough, so we'll put a key value cache in front of it. Or perhaps when our relational database isn't fast enough, We'll grab a new SQL database that will allow us to speed up our queries by scaling horizontally. We can grab one or many data stores for each microservice. So here's another money shot. Grab your phone or grab these slides from robrich.org. My recommendations: use database as a service whenever you can. Outsource the problems of, can you restore to this particular point in time? Did you back up the data store? The cloud vendors will be able to handle that just fine. And then you can sleep at night. If the data store goes down, let them get it back online. Use automation if you have more than one server to do that mechanism of enrolling it in authentication and backups. You don't want to have a data store that is, well, not backed up. Choose SQL by default. SQL is probably the one that you have if you have a monolithic database, and that's because that engine has been tuned for decades and allows you to do really elegant and speedy and ACID compliant mechanisms. If you need a particular data store and you have an exact match to that other type of store, then go grab that store and use that for storing the time series or key value or JSON data that you need in exactly the format that you need it. Or reach for a hybrid database that is able to do the basics of the SQL that you need together with the other things that you need from the other store. This was a lot of fun to dig into databases in the microservices world. If you're watching this video online, grab me on Twitter at rob_rich and grab these slides at robrich.org. What are our questions?
Thanks, Rob. Thank you very much for your presentation. Very insightful and actually very good and thorough catalog of databases. And I've been looking at work at some of those, so that's pretty cool. I do have a couple of questions to present to you before we go into our next portion and final steps of the conference. So the first one of these is, how would you deal with the data persistency across multiple instances in this micro database world? Does using a micro database oriented design instead of database monolith make this issue harder to tackle?
Yes, when we need to replicate our data between microservices, that's when we would choose an enterprise service bus where we could publish our data from one micro database to another. And then the other microservice, maybe it's a headless microservice where it has no public facing interface, but it just listens to that feed coming off the enterprise service bus and saves the data in its own database so that we can then query it using other tools.
All right. And the second, thank you. So the second question, security is the theme of the day worldwide. Can we have big security problems when we apply databases in the microservice world? What can we do to strengthen the security layer?
Yes, it's really easy to accidentally forget the security on our data store. And that's one of the reasons probably that we're stuck in a monolithic database, if you are. Because if we lose a microservice, well, we can just dump that container and spin up a new one. If we lose a micro database or even a monolithic database, now we're really hurting. When we talk about security breaches, we don't talk about that they were able to pop my server. We talk about data loss. So as you move from monolithic databases to micro databases, you want to ensure that you have that automation to ensure that the security boundaries are validated automatically, that authentication for this data store is crafted automatically, that we don't need to manually start doing all the things. Now, let's definitely build the walls around that, but as part of the benefit of a micro database approach is we can then pin another boundary around that micro database and the microservice that owns it. Any traffic coming to this micro database that is not from this microservice, we know to be bad and we can block it. Because we've now blocked that traffic coming into this micro database from anything else, we have that additional layer of security to know that this data is in good hands.
All right. Thank you very much, Rob. Thank you for joining us today. And it's been a pleasure. And
yeah.
And this is it. This is our last speaker. Thanks. Take care. I'm gonna share my
Thanks
screen
for having me.
See you later.
Bye-bye.
Bye. So, hi everyone. This is it. This was our last, wow, time flies. And we're already at the end of the day, but before we wrap up, we have one last giveaway. And I've been told that it's been a very tight race. And the winner of our last giveaway has been Isabel Teixeira. So congratulations to her. It's been awesome. We had a lot of questions, a lot of votes. Also, thanks for the people that took the time to vote and to help us get the best out of, like, the best questions and the best answers as well out of our speakers, and make this conference really worthwhile. Before you tune off, we do have a couple more things to say. Not all from me, because you've heard enough, I guess. But before we move, and I'll pass the word to Rita, who will be joining this streaming in a moment. We'd like to share with you and announce that we have done the first big step towards CommitPorto 2021, which is something that's very close to our heart, which is to select the color of next year's edition. You can see around me that this year's color has been purple. I'm not sure if that was what caused COVID or not. That's still, the jury's still out on that. But for next year, if I can move the slide forward, we can have this beautiful logo. Goes really well with the black t-shirts for those that like it. And it's been really great. And I'm gonna now have to tune I think I need to promote someone to be a presenter on Zoom. Zoom has been awesome, but also a challenge for me. I don't know if Rita, are you there yet?
Yes, Simon. Hi.
The stage is yours. Shine.
Okay, thanks. So, hi guys. I'm here talking in representation of the CommitPorto and alumni. So, first of all, thanks to all of you for coming today, and I hope you all enjoyed this year's special edition of CommitPorto, this time home edition due to COVID-19. So I would like to say a few thank you notes. First, to our speakers. Thank you to all of our speakers. It was a great review. Due to all the circumstances, they board with us on this home adventure. So thanks again to all of you. I would also like to thank our partner, the Department of Informatics Engineering of FIUP, who have always been so kind to support us in all our events and are once again proud partners of CommitPorto. Also, I would like to thank all of our sponsors, without whom this day would obviously not be possible, and CommitPorto would not be able to join so many people and be this event that we are all of organizing. I would also like to mention them. So thanks to Critical Tech Works, Darwin Interactive, Bitwise IMC, OutSystems, Bosch, and finally Losch. So going with the sponsors ready, I would also like to thank you and also thank our amazing team, our organization team from Commit, which I would like to ask them to also come forward on this call so everyone can see them and see the people who some have been talking to in the last months, and also those faces that you usually see but are working on the background. So commit is possible and keeps happening each year. So they are appearing bit by bit. Most importantly, to all our participants, who are the people that we make for. We aim to bring the new and subjects to you. So we hope this year. We hope you enjoyed all books. We also want to tell you that if you had not have the opportunity to see all these days talks, you will have the opportunity to watch it later on YouTube, or even if you want to rewatch it. So please be our guest and I think that's it. So you already saw our colors for next year. So that's it. Thank you all and see you next year. Simon, back to you if you want to finish.
Well, I'm just going to say thank you again. It's been a pleasure. Thank you for inviting me to host the conference. Great job, guys, putting amazing panel. I really enjoyed it. And having this front row seat and being able to talk with the speakers is a privilege. And so thanks to all of them. And see you next year. Take care, everyone.
Bye.
Signing off. I'm going to do something amazing, maybe. I'm going to fail miserably, but I'm going to try. Let me see if I can do this.
Da canção e paro pouco para dormir. É tarde para voltarmos atrás. Já nem há motivo algum para rir. É como ouvir alguém dizer ver é só procurar uma razão para virar a dor para dentro.
So, thank you, everyone. Take care. I'm gonna close the loop now and close the live transmission. See you later.